Hello. Hello. Yes, hello everyone. Welcome on YourPedia platform. I hope you all are fine, preparing well. And yes, you are with very high confidence this time and full of energy, happy. That I feel this time. So, guys, this time is very much crucial for you. Okay, because those of you who are practicing more and more question, what I feel, they will have an edge in your upcoming examination. Because before going to any examination, guys, some kind of practice is required. Like suppose if you want to score well in a cricket match, and if you go without practicing, then there are chances. There is luck also, but some kind of practice is required. And for that only, guys, we are discussing here. We are solving more and more questions, all concept questions, guys, we are discussing through these NPTEL assignment. And earlier also, guys, we discussed, and I think this is very clear to you also now, there is a very high correlation between those NPTEL assignments and GATE questions, GATE examination. Okay, some question we find in those, like, were there in those assignments in year 2014 and 15. Those were earlier asked in GATE examination also. Okay, so that we can predict. And yes, there is a high probability that, like, the question which actually we are covering through these assignment series, there are high probability of coming those type of questions in your upcoming examination. Other than that, like, suppose if you will forget about that also, practicing is more important. Okay, so in today's session, guys, we are going to solve 100 plus questions from thermodynamics, and I hope you all have downloaded those that workbook that we have shared with you. So I hope you all found that workbook with you, all are having that workbook with you, because that is required. Because each and every content you will not be able to note it down here. So if you are having workbook, you will be able to practice more and more questions very quickly. Okay, so guys, first 50 questions, what I feel, those are standard typical GATE level questions. Okay, not that much easy, not that much difficult, but they are in level with the GATE examination. First 50 questions. Question number 51 to 65, they are class problems, master level problems. If you have solved those problems from 51 to 65, means your GATE preparation is excellent, your GATE preparation is very good. Okay, and from 65 to 75, those are typical standard 1 marks question. From 75 to, again, onwards 100, those are class problem, guys. So if you are able to solve those problems, like from 51 to 65 and 75 to 100, means your preparation is very good. Okay, first 50 questions are also very important, because they are going to give you in-depth idea about this subject, thermodynamics, and you will be able to prepare, you will be able to recall all those basic concepts. Okay, so time is very important, guys. So let's start the session. The session is going to be long, so it's my request to all of you, please have some kind of good internet connectivity. I will also try to ensure all those things. And yes, please keep all those things with you, like water, anything. So, and yes, the confidence, the energy is required, because when the session is long, so you need to have that kind of energy also. Okay, so let's start this session, guys. Let me put it here. Question number 1 in front of you. So first 3 problems are from Clausius-Clapeyron equation. There are these times, like from year 2018-19 onwards, the examiner are asking much questions from this particular topic, Clausius-Clapeyron equation. Okay, so this is first question from that only. Please try to answer this question. The vapor pressure of dichloromethane at 24.1 degrees Celsius is 53.3 kilopascal, and enthalpy of vaporization is 28.7 kilojoule per mole. So this is very important. The enthalpy is given to you in kilojoule per mole. Okay, ठीक है बच्चों? He is asking you estimate the temperature at which vapor pressure is this. So 2 pressures are given, 1 temperature is given, HFG is given. He is asking you another temperature. Very simple, typical GATE level problem, guys. So which equation you need to use? एक equation होती है, there is a Maxwell relationship that you can easily recall also, SPVT. Okay, this is a shortcut actually to get that Maxwell relationship. Del S by del V at constant temperature, that is equal to del P by del T at constant V. Okay, This is the Maxwell relationship, very, very important Maxwell relationship. And from this, easily we can write, like during phase change, the pressure, temperature, those are like you can say independent of the volume. So you can write this equation as dP by dt for the phase change. Okay, dP by dt for the phase change, this is equal to Sg minus Sf, change in entropy, divided by Vg minus Vf. Okay, something like this is the final equation, guys. Further you can solve this equation, integrate, and you can get some more equation, something like this. मैं आपको drive कर देता हूं, but those who know directly that formula, they can try to solve and they can tell me the answer. Janish, that I cannot ensure you this time, because all those sessions are live only. All 100 plus assignment series, those actually we are conducting, all are live sessions only. Okay, you're not going to find those like after the session, all those we are privatizing, so that I cannot ensure. So you need to attend the live session only. Chali, that is a restriction here. So, and this Sg minus Sf, you can write it as HFG, which is the latent heat of vaporization, divided by T saturation, okay, into Vg minus Vf. I hope this equation is very much clear to all of you guys. ये equation आप सबको बहुत clear है बच्चों. Yes or no? There is one assumption which we go with in this analysis. Vg, the specific volume of gas, is very, very high as compared to the liquid. The specific volume of the saturated gas is very, very high as compared to liquid. तो हम इसको क्या कर देते हैं बच्चों, we simplified this equation something like this, HFG by T saturation, and if we'll assume कि this is going to follow the ideal gas equation, so PV equal to RT, so Vg is nothing but that is equal to RT by P. Okay, so if you'll put it here, RT by P, you will have an equation HFG into P by R T saturation square. Okay, T saturation square. This is a very, very important equation, guys, which you need to remember. Otherwise, if you will follow this step also, then also in seconds you are going to get this equation. तब भी seconds में equation आपके पास आ जाएगी बच्चों. Okay, then further if you want some more important relationship in terms of P1 P2, then आपको क्या करना पड़ेगा, you need to integrate this equation. So you can take temperature term this side, pressure term this side. So here not R, this is not R, this is P. Okay, this is P. मैं इसको black से ही लिख देता हूँ, so that there will be proper uniformity. So this will be P, because P will go up, HFG into P divided by T saturation square into RT, R. Okay, so you can write it as dP by P equal to HFG by R T saturation square into dt. Okay, further you can integrate both sides from 1 to 2. 1 to 2 आप इसको क्या कर सकते हो, integrate कर सकते हो. You will have the equation ln of P2 by P1, ln of P2 by P1, this is equal to how plus G, how H plus G, H plus G what? Okay, this is, guys, this is very simple thing. This time at least you need not to have these kind of confusion. Guys, entropy change, Sg minus Sf, this is nothing but change in entropy during phase transformation. Okay, change in entropy during phase change. Okay, Sg minus Sf. Sg is the entropy of the saturated liquid gas. Sf is the entropy of the saturated liquid. This is the entropy change during phase change, and this is nothing but heat transfer. ds equal to dq by t. And what is the heat transfer during phase transformation? That is HFG, means Hg minus Hf divided by T saturation. You got the idea, guys? So this is very simple equation, guys, and delta S is equal to dq by T. From that only we are writing this equation. Okay, these are very simple thing actually. Okay, you need to recall, you need to have some basic understanding, guys. This time is not that much, we cannot go into much more detail because these things are very much direct and simple. So ln of P2 by P1, this is equal to HFG. This we can assume it constant. This is another assumption here. We are assuming this HFG as constant. HFG को हम क्या मानते हैं बच्चों? This we assume as a constant. R is also a constant. This is T to the power minus 2. So you will have minus, because you will have T to the power minus 2 plus 1. And in the denominator also you will have minus 2 plus 1. Okay. So minus 2 plus 1, you will have minus 1. That's why I'm writing it as minus 1 by T. So it will be minus 1 by T. And the limit will be 1 to 2. Okay, so further simplification will result in ln of P2 by P1 is equal to HFG into R into minus 1 by T2 plus 1 by T1. Okay, this is the final formula, guys. This is the final formula which you can directly remember also. Otherwise, you can also get this very easily. Yes or no, guys? ln P2 by P1 equal to HFG by R into minus 1 by T2, okay, minus 1 by T2 plus 1 by T1. ठीक है बच्चों, is that clear? Now if you will go with the basic data which is given to you, जो आपको दिया हुआ है data, what is data guys? What is this? This is T1. Remember one thing, temperature you need to put in degree Kelvin. Don't put temperature in degree Celsius, otherwise your answer will be wrong. So this is temperature T1. Temperature T1 is equal to 273.15 plus 24.1 degree Kelvin. So this is T1. Okay. Similarly, what is T2? T2 we want to find out. T2 तो अपने को निकालना है बच्चों. T2 हमें निकालना है. What is P1? Sir, P1 is nothing but 53.3 kilopascal, and sir, P2 equal to 100 kilopascal. All these things are given to us. All these things are given to us, guys. Okay, HFG is also given to us 28.7 kilojoule per kilomole. Why kilojoule per kilomole, guys? When you are putting HFG in kilojoule per kilomole, listen very carefully. R you need to put in what? R is will become universal gas constant. So this thing, which I'm writing here, when you are putting this in kilojoule per kilomole, okay, this in kilojoule per kilomole, then this R will be universal gas constant, guys. Okay, don't put R as a characteristic gas constant, and don't worry about that. Okay, sir, what R I need to put? It will be universal gas constant by molecular weight. No, when you're putting this HFG in kilojoule per kilomole, then this R will be universal gas constant. So if you'll put it here, all the values, ln of P2, which is 100, and this is 53.3, there is no need to change the units here because these are in ratio, guys. P2 by P1, there is no need to change the units. Okay, even they are in bar or anything, there is no such need to change the units. Okay, HFG, again, if you will put HFG, we kar dete hain 28.7 kilojoule per mole. Okay, 28.7 kilojoule per mole. Okay, this you need to remember, kilojoule per mole. So here you can write it as 10 to the power 3 joule per mole. Okay, this will become joule per mole. Divide by 8.314. The unit of this also joule per mole. You need to balance the unit, guys. Otherwise, you will not get the answer. आपको यूनिट्स क्या करनी पड़ेगी? बैलेंस करनी पड़ेगी. HFG, I am putting it in joule per mole. So this also you need to put in joule per mole. There some students, they are having confusion. Sir, universal gas constant is 8.314. This is joule per mole Kelvin, fine, or it is kilojoule per kilomole Kelvin. Anyway, you can write. If you are writing it in 8.314, like something like this, you can write it as kilojoule per kilomole or joule per mole. Okay, so when you are putting this in joule per mole, then this will also be in joule per mole. This is already in joule per mole, but this also you need to write in joule per mole because this we are putting in joule per mole. You got the idea, guys? So you need to multiply here 10 to the power 3, and the answer here, the unit will be balanced, then only you are going to get the right answer. So minus 1 by T2 plus 1 by T1, and T1 is nothing but 273.15 plus 24 point, let me check, what is the initial temperature, guys? What is the initial temperature here? 24.1 degree Celsius. So put all the value and tell me what answer you are getting, guys. आपका आंसर क्या आ रहा है? What T2 value you are getting? There is only one unknown, T2. In degree Celsius, you need to tell me the answer, guys. You need to tell me the answer in degree Celsius. What T2 you are getting? Students are saying, sir, we are getting option A, 41.27 degree Celsius, and this is very right, guys. This is the right answer for this question. If you are getting 41.27 for this question, means your answer is very right. ठीक है बच्चों? Okay. I think ये चीज आपको समझ में आई होगी. Why I am multiplying it with the 10 की power 3. Okay, this I am putting in kilopascal. What I mentioned, both are in the same unit, so there is no need to convert their units. But this, when you are putting in joule per mole Kelvin, this also is required to be in joule per mole, Kelvin. Then joule per mole, then only you will have the balanced unit. The unit will be balanced, and then only you are going to get the right answer. ठीक है बच्चों? So please tell me how many of you got the answer for this question number 1. Okay बच्चों, ठीक है? Is that clear, guys? So let me again put the question in front of you, and you can check how many of you are getting the right answer for this question, guys. Very simple question. In detail, we have solved. Okay, bye, guys. Let us move to next question, question number 2. So this is question number 2, guys. The molar volume of a certain solid is this. So he is giving you the molar volume. Certain solid is this at 1 atmospheric, this much temperature, its melting temperature. So this is the saturation temperature. Saturation temperature is given to you 950.75 Kelvin. This is T saturation. The molar volume of the liquid is also given to you guys. So means indirectly he is giving you the change in volume, like molar volume of the liquid minus molar volume of the solid. Okay, generally we write it for liquid to gas, but this equation we can use for solid to liquid conversion also. Okay, so this is also a phase change process, solid to liquid, which is a kind of fusion process. So we can find out enthalpy of fusion also using the same Clausius-Clapeyron equation. Okay, so here this VL minus VS, this is given to you. Okay, so this is specific molar volume of the liquid, this is molar volume of the solid. Okay, so this is the pressure and this is the T saturation. He's saying at 100 atmospheric pressure. So P1 is nothing but 1 atmospheric, P2 is nothing but 100 atmospheric, P2 is 100 atmospheric, and T equal to T saturation means T melting, which is given to us 950.75 Kelvin. Okay, so he is asking you the melting temperature changes to, melting temperature भी बोल रहा है change हो रहा है. So he has given you what T1 and T2. उसने आपको T1 और T2 दे दिए, means he has given you T1 and T2. So T1 melting temperature T1 is 950.75 Kelvin and T2 equal to 951.26 Kelvin. Means from this data guys, indirectly he is giving you dp by dt. आपको क्या दे रहा है बच्चों? dp by dt. What is dp by dt? It is P2 minus P1 divided by T2 minus T1. You got the idea guys? If you got this, then this question is very much easy for you, because he is giving you P1, he is giving you P2. He's saying at this pressure, this is the melting temperature. At this pressure, this is the melting temperature. Means he is giving you dp by dt indirectly. Okay. Then he is asking you calculate the enthalpy and entropy change. आपसे क्या पूछ रहा है? Enthalpy पूछ रहा है और entropy पूछ रहा है. Okay. So first, it is good to find out entropy. So this is nothing but entropy change means Sg Sl minus Ss, specific entropy of the liquid minus specific entropy of the solid, divide by what guys? अब यहाँ पे इस पे किसको डिवाइड करोगे? Divide by Vg Vl minus Vs. I'm using simple first equation only guys. I'm using this equation only. Which equation I'm using? dp by dt equal to Sg minus Sf. This is for the vaporization process guys. dp by dt for the vaporization process. Sg entropy of the saturated gas minus Sf divided by Vg minus Vf. But here, you know, this is not a vaporization process, this is a fusion process. And for fusion process, you need to write it here Sl minus Ss, solid, L stands for liquid, divided by Vl minus Vs. Okay, so this is also directly given to you. ये आपको directly दिया है उसने. Only you need to balance the units and easily you will get the entropy change. So please tell me the answer guys. How many of you are getting the answer for the entropy change? Okay. Please tell me the answer guys. How many of you are getting entropy change? ठीक है. Please find out first the answer for the entropy change. देखो बच्चों को कंफ्यूजन कहाँ होगा? Sir, how to put the units? P2 is 100 atmospheric, it is 1 atmospheric, fine. So means P2 by P2 minus P1 is 99 atmospheric, fine. But you need to convert this in kilopascal, because then only you are going to get the answer. You need to convert this into kilopascal. So this P2 minus P1, 100 minus 1, it is 99 atmospheric. But in 1 atmospheric, how much kilopascal you are having? Or like if you write it in Newton per meter, then you need to multiply it with the 1.0325. Yes or no? Okay. 101,325. Okay, because 1 atmospheric equal to 101.325 kilopascal. You can write it in kilopascal, or this is equal to 101,325 Newton per meter square. Okay, Newton per meter square. तो इसको किलो में लिखना है तो किलो में लिख लो, because then only the entropy you will get in kilojoule per Kelvin, something like that. Okay, but you need to carry out this conversion, otherwise you are not going to get the answer. So P2 minus P1 is 99 atmospheric, 100 minus 1 it is 99 atmospheric. So you can write it something like this, या इसको ऐसा लिख लो किलो पास्कल में. This is P2 minus P1 divided by T2 minus T1, so it will be 951.26 minus 950.75. This is equal to the entropy change for the fusion process. The entropy change for the fusion process divided by VL minus VS. This is also given to you guys. 163.3. 163.3 minus 161. Okay, centimeter per mole. 161 सेंटीमीटर क्यूब. अभी देखो आपको कन्वर्ट करना पड़ेगा बिकॉज एसआई यूनिट यू नीड टू यूज दिस इज सेंटीमीटर क्यूब पर मोल. Per mole is fine because this is a molar volume. This is a molar volume, but centimeter cube. So you need to convert. You know, guys, 1 centimeter is equal to 10 की power minus 2 meter. Okay, 1 centimeter equal to 10 की power minus 2 meter. So 1 centimeter cube equal to 10 की power minus 6 meter cube. Okay, so if you will convert this also in SI unit, so you need to multiply it with the 10 की power minus 6. 10 की power minus 6, so that it will become meter cube per mole. This is in meter cube per mole. Okay, this is in what, kilopascal. So entropy change, if you will balance the units, you will get in kilojoule per mole. Okay, kilojoule per mole. ठीक है बच्चों. So because this is in kilojoule per mole, and he is asking you answer in also in kilojoule per mole. He is asking you the answer in kilojoule per mole. If you will check the unit, guys, for the entropy change, kilojoule per mole, because there is no such mass basis पे, there is no such volume given. Molar volume is given to you. What do you mean by molar volume? The volume per mole of a substance, means meter cube per mole. So this is molar volume. So entropy you are going to get in kilojoule per mole. So carry out the calculation and tell me what is the entropy of the fusion you are getting, guys. अब देखो, this much understanding you need to have, like how actually conversion I am carrying out, why I am multiplying it with 10 की power 6. Okay, and how you are getting this answer in kilojoule per mole. Okay, so please tell me the answer for entropy change in this process. ठीक है बच्चों, units you need to keep in mind. Units का आपको ध्यान रखना पड़ेगा because he is asking you the answer in kilojoule per mole. Kilojoule per mole, he is asking the answer in this. ठीक है बच्चों. So if you check the answer, you are going to get answer 43 something. Okay, so those of you are getting answer 43, they are very right. ये जो आंसर आएगा आपका 43 किलोजूल पर मोल. Okay, then second part he is asking you the enthalpy change, delta H fusion. Okay, enthalpy change in the fusion process, and it is nothing but the T saturation into entropy, delta S fusion. So melting temperature या saturation temperature, if you multiply by the entropy change of the fusion, you will get the enthalpy of the fusion. Okay, so you need to multiply it with the temperature, melting temperature. So this is first melting temperature, guys. This one you need to use 950.75. 950.75, and this he is asking you in joule per Kelvin mole. Okay, joule per Kelvin mole. ठीक है बच्चों, joule per Kelvin mole. Please check and tell me how many of you are getting the answer. Option A, students are saying, sir, we are getting option A. No, option A is not right, guys. Option A is not right for this question. ठीक है, option A is not right. Option C is the right answer for this question. You need to check, guys. Option C is the right answer for this question. Please check. Option C. This is the right answer, guys. Option C is the right answer. So two things he asked you. First is the enthalpy and the second one is the entropy. Enthalpy, entropy, both you need to check. Okay, I think first you are going to get in 45.23. पहला चेक करना. Entropy मेरे ख्याल से इसमें ये 45.23 आएगा, and then if you will multiply it with the temperature of the fusion, then you are going to get this answer. Okay, because we are finding out this per mole. Okay, हम इसको क्या निकाल रहे हैं, per mole. Okay, so this you are going to get for the entropy, this is for the entropy, and this is for the enthalpy. Okay, answers are reversed. Initially he has mentioned here enthalpy and entropy, but answers are given in reverse order. Okay, answers आपको reverse में दिए हुए हैं. He is asking you enthalpy, entropy. So I think this one you will get for the entropy 45.23, 45.23, so 45.23 check कर लेना इसको, and this you need to multiply with 950.75 multiply by 45.23. Okay, this you are going to get close to 43 kilojoule per mole. Okay, so this is your enthalpy, this is enthalpy, and this is entropy. Entropy is in joule per mole Kelvin. Okay, joule per mole Kelvin. ठीक है बच्चों, so I hope you all got the answer for the entropy change, joule per mole Kelvin. Units you need to check. अब joule per mole में पूछ रहा है, so here you need to write it here, multiply by 10 की power 3 also, because he is asking you in joule per mole, so you can write it here 10 की power 3. Why? Because you need to use the SI units. Okay, because this time I checked entropy, he is asking you in joule per mole. Okay, so this already we have converted into meter cube per mole, so this is in SI units, this is already in SI units, so this also you need to convert in SI units, so I'm here multiplying it with the 10 की power 3. So initially I thought कि entropy you need to find out in kilojoule per mole Kelvin, but he is asking you the entropy in joule per mole Kelvin. That's why here I'm converting this kilopascal in Newton per meter only. Okay, Newton per meter square only. So 10 की power 3 into 99 into this, divided by this. If you will solve this, you will get entropy of the fusion. Okay, something like this, 45.23 joule per mole Kelvin. And this, if you will multiply by the melting temperature, you will get the answer enthalpy change of the fusion 43 kilojoule per mole. Okay, please confirm, guys. I hope you all got the answer for this question. Please check and confirm. Okay, the option C is the right answer for this question. Please check and confirm, guys. Is that clear? Can we move to next question? Yes, Jagdish, very good, your answer is right. Jagdish, bilkul sahi. Others also, guys, please tell me how many of you are getting the answer for this question. Very good. Chaliye, let's move to next question. This is also on the same line but slightly different. Okay, slightly different, and you need to practice this also. When benzene freezes at 5.5 degrees Celsius, means this is the melting, this is the freezing temperature, so this is T saturation. Okay, melting benzene freezes at this temperature means this is a T saturation. Its density changes from this, so this time he is giving you the density changes. You know, guys, specific volume is just reverse of density. Okay, specific volume is just reverse of density. So when you are having the density changes, means indirectly he is giving you the specific volume changes. He is giving you like something like this, VL and S solid. Okay, so both are given to us. Its enthalpy of fusion is this. Estimate the freezing point of the benzene at 2000 atmospheric. Now, guys, this is very similar problem, but there is a slight change in data. Okay, and I think if you will apply your mind easily, you will be able to answer this question. So same formula you need to use, dp by dt, this is equal to entropy change in the fusion process, okay, divide by volume change in the fusion process. अभी क्या हो रहा है, melting हो रहा है, क्या हो रहा है, freezing हो रहा है ना. Okay, freezing हो रहा है, so it will be specific volume of the solid minus specific volume of the liquid. Okay, so you can use it here. But यहाँ पे आपको density दिया, he has given you the density, so this data you are going to get by reversing it. तो इसको आप reverse करके भी लिख सकते हो. This you can write it in reverse order also. Okay, 1 by, like suppose 1 by density of the you can say liquid solid, freezing process है, so this will be solid minus 1 by density of the liquid, something like this. You got the idea, guys? So he has given you the density, this is the density, but again you need to check the units. The densities are not in SI units, you need to convert these in SI units. इनको आपको SI units में convert करना पड़ेगा बच्चों. So let me write it here, the specific volume equal to 1 by rho, and suppose if I will write it here, the density changes from this to this, means this is the density of the liquid, so this VL equal to 1 by rho L, and rho L is nothing but 0.879. Okay, so grams per centimeter hai, so this you can multiply by 10 की power minus 3 to convert grams into kg, divide by centimeter cube. So centimeter cube means you need to divide it by 10 की power minus 6, then only you are going to get this in kg per meter cube. Okay, and the specific volume you will get in meter cube per kg. Okay, so the answer, right answer will be 1 by 0.879 into 10 की power 3. Okay, 0.879 into 10 की power 3. This is VL. Okay, this is VL, and on the same line you can write it here VS also. This is 1 by 0. Now I can write it directly 0.891 into 10 की power 3. I think you got the idea why I am multiplying it with the 10 की power 3. मैं इसको 10 की power 3 से क्यों multiply कर रहा हूं बच्चों? I hope this is very clear to you, because unit conversion is required. Otherwise, you will face difficulty, guys. Unit conversion is required. Gram per centimeter cube we are converting into kg per meter cube. Okay. So he has given you the change in pressure. Change in pressure आपको दिया है बच्चों. The benzene freezes. The enthalpy of the fusion is this. Estimate the freezing point of the benzene at this. So means what he's saying, guys, when benzene freezes at this, its density changes from this. Means initially, actually he has not mentioned, because these are the NPTEL assignments and they feel you know about all those things. So the initial pressure P1 is nothing but 1 atmospheric. Okay, so at 1 atmospheric the benzene freezes at this temperature. 1 atmospheric पे बच्चों 1 atmospheric पे benzene freezes at this temperature 5.5 degrees Celsius. So he has given you P1, he has given you P2. Okay, this data is not directly given, but I am telling you because then only you will be able to solve the question. So P1 is the initial pressure, which is 1 atmospheric. At 1 atmospheric, this is the fusion temperature, and these are the density changes. This is your HFG, this is your final pressure. So from this, guys, initially you are going to get the dt, change in temperature. Okay, you are going to get the change in temperature. Okay, and after calculating the change in temperature, what is change in temperature, guys? Means fusion temperature final, means the fusion temperature final minus fusion temperature initial. Yes or no? So can you solve this, guys, and can you tell me the final fusion temperature? Dt is nothing but temperature of fusion final means 2 minus temperature of fusion 1 means initial. This is nothing but dt, change in temperature. So from this data, because this is given to you, okay, all these things are given to you, because this you can write it as what? इसको आप कैसे लिख सकते हो बच्चों? This entropy change you can write it as HFG, enthalpy change of the fusion, delta H of fusion, okay, divided by temperature of fusion, okay, T fusion into 1 by rho S minus 1 by rho L. Okay, so this is given to you directly, enthalpy change of the fusion. Okay, this is given to you, T fusion initially. From this easily you will get delta T, change in temperature. This you are going to get, and this change in temperature is nothing but fusion temperature final, fusion temperature initial. Fusion temperature initial is 5.5 degrees Celsius. Okay, so this is given to us 5.5 means 5.5 plus 273.15 degree Kelvin. Okay, so this is initial fusion temperature. Easily you will get final fusion temperature. So now tell me, guys, what answer you are getting? What final fusion temperature, guys, you are getting? Okay, but again when you are putting the pressure, you need to keep in mind, guys, आपको एक चीज ध्यान में रखनी है. When you are putting the pressure P2 minus P1, which is 2000 minus 1, this is in atmospheric. ये किस में है? Atmospheric में. So again you need to carry out the conversion. क्या करना पड़ेगा? 101325. Okay, so this conversion you need to carry out. This is dp by dt is equal to delta H fusion. Okay, delta H fusion divided by T fusion into 1 by density of the solid minus 1 by density of the liquid. ठीक है बच्चों? Yes, please tell me how many of you are getting the answer now. ये उल्टा हो जाएगा because density of the solid will be higher. Okay, density of the solid will be higher. So yes, all things if you will put, you will get the delta T. So now can you tell me, guys, what delta T you are getting? What delta T you are getting? ठीक है, what value of delta T you are getting? Yes, guys. Any answer from your side, guys? Please tell me the answer. Is that clear? Please check it again. Let me write it here in front of you, or let me frame some kind of formula for you. So delta T, this we want to find out, and this delta T is nothing but this delta P into fusion temperature into the specific volume changes. The specific volume changes आप लिख सकते हो. The specific volume here you can write it for liquid minus solid. Okay, liquid minus solid divided by delta H fusion. So this kind of formula you can frame. This I'm writing from this only, guys. यहीं से मैं लिख रहा हूं. So this I'm writing from this only. Delta T, the change in temperature equal to delta P into temperature of fusion into specific volume of liquid minus specific volume of solid divided by delta H fusion. This is directly given to you, delta H fusion, which is nothing but 10.59 kilojoule per kilomole. This is given to you. Okay. Density changes are given to you. Molar mass is given to you. Why this molar mass is required, guys? Why this molar mass is required? That is a very important point in this question. Why this molar mass is required? You know, guys, when we are using those SI unit, so we want HFG in kilojoule per kg. We want this HFG in kilojoule per kg. Yes or no? So how to get this in kilojoule per kg? You know, guys, this is given to us in kilojoule per kilomole. 10.59 kilojoule per mole. किलोजूल पर मोल. So if you will divide it by molecular weight, अगर आप इसको molecular weight से divide कर दो, okay, if you will divide it by molecular weight in what, guys? ग्राम पर मोल, या तो आप इसको बोल सकते हो ग्राम पर मोल, okay, या kg per kilomole. Yes or no? So if you write this in kg per kilomole, so this is in gram per mole. In gram per mole also you are going to get this 78.12 gram per mole, or in kilojoule kg per kilomole also you are going to get this in this only. Okay, but अपने को क्या चाहिए? We want this in kg per mole only. That is a very important point, guys. This we want in kg per mole. Why? Because this is in kilojoule per mole. Then only you will be able to balance the units. So 78.12 into 10 ki power minus 3 kg per mole. You got the idea, guys? 78.12 multiply by 10 ki power minus 3 kg per mole. Okay, so let me write it here, the molecular weight here. So this is 78.12 into 10 ki power minus 3. This is in kg per mole. Okay, this is in kilojoule per mole. So this will cancel out. You will get the enthalpy in kilojoule per kg. Okay, you are going to get the enthalpy in kilojoule per kg, which is nothing but 10.59 into 10 की power 3 divided by 78.12. ये आपको यूज करना पड़ेगा बच्चों. In this expression here, in place of this delta H fusion, this you need to replace. इसको किससे replace करना पड़ेगा? This delta H fusion is nothing but 10.59 into 10 की power minus 3, 10 की power plus 3 भाई guys, because ऊपर जाएगा तो it will be 10 की power 3, 10 की power 3 divided by 7.78.12. Okay, this delta H fusion you need to put this. No, guys, you need to attend the live session only. That I cannot ensure कि video will be available after the live session or not. ठीक है बच्चों? So if you will put all the values, अभी अगर आप सारी values put करोगे, you will get the temperature, the final temperature, the change in temperature initially. The change in temperature you are going to get 6.3. This is change in temperature, guys, and the final melting temperature TF2 is nothing but TF1 plus 6.3. So it will be 5.3 plus this, so it will be 278.65 plus 6.3, which is 284.9 Kelvin. 284.9 Kelvin. Okay, so what actually he is like what one difficulty he made it in this question. He has actually given you the HFG in kilojoule per mole. Okay, so this you need to convert in what? Kilojoule per kg. How? By dividing it by the molecular weight. आपको इसको क्या करना पड़ेगा? You need to divide this by the molecular weight. Okay, and this molecular weight I'm putting in kg per mole. Why? Because mole it will be cancelled out, then so that you will get answer in kilojoule per kg. What is the point? Because this we want in kilojoule per kg. Okay, now here if you'll put all the answers, then only you are going to get the answer. अभी एक और याद रखना, when you are putting this in kilojoule per kg, so this delta P you need to put in kilopascal. Okay, this delta P you need to put in kilopascal. So now here you can write it here 101.325. Okay, these all things are type of all these changes you need to make. If you are putting this in Pascal, then here also you need to use joule per kg as a unit. If you are putting this in kilopascal, then this you need to put in what? Kilojoule per kg. So this, because we calculated this in kilojoule per kg, so this delta P you need to put in kilopascal. Okay, got the idea, guys? Tf is the fusion temperature initial, which is nothing but 5.5 degrees Celsius to 273 plus 5.5, you will have 278.5. So this is fusion temperature. All these things are also given to you. This is delta H fusion. Delta T you are going to get 6.3. Delta T change in temperature you will get 6.3, which is nothing but the fusion temperature final minus fusion temperature initial. So fusion temperature final equal to fusion temperature initial plus 6.3. You will get the answer 278.65. This is initial fusion temperature. 5.5 plus 273.15. This is initial fusion temperature plus 6.3. This is final fusion temperature 284.9 Kelvin. And this is the right answer, guys, for this question. थोड़ा सा डिफिकल्ट उसने बना दिया था आपके लिए, बट इफ यू विल गो विद ऑल एसआई यूनिट्स, इजीली यू विल गेट द आंसर. नो 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 नो, द प्रेशर विल नॉट बी इन मेगा पास्कल. प्रेशर मेगा पास्कल में नहीं होगा बच्चे. Okay, it depends, like whether you are putting it in pressure you are putting in kilopascal. There are two options. You can put in kilopascal or you can put in Newton per meter. Okay, if you are putting it in Newton per meter, then enthalpy also you need to put in the same units. Okay, because for volume all SI units you need to use. Okay, otherwise first what you can do, you can put all in SI units only. सबको आप SI units में put कर लो बच्चों. अगर आपको यूनिट्स में दिक्कत आ रही है ना बच्चों, what you need to do, you need to put all these in SI units only. So this is 1999 into 101325, इसको SI units में put कर दो, इसका SI unit ले लो. This is 278.65, इसका SI unit ले लो. इसका भी क्या ले लो? SI unit ले लो बच्चों, इसका भी SI unit ले लो. 1 by the density of the liquid, which is 8.79 minus 1 by 0.891. इसको मल्टीप्लाई करना पड़ेगा, यूनिट कन्वर्जन करना पड़ेगा, बिकॉज दिस इज इन ग्राम पर सेंटीमीटर क्यूब. ओके, दिस इज इन ग्राम पर सेंटीमीटर क्यूब. ओके, तो आपको मल्टीप्लाई करना पड़ेगा. आई टोल्ड यू टू मल्टीप्लाई विद बाय 10 की पावर 3. ठीक है, ऊपर जाके क्या हो जाएगा? इट विल बी 10 की पावर -3. ठीक है, डिवाइड बाय आपको क्या करना पड़ेगा? 10.59 इंटू 10 की पावर 3. This also I'm putting in joule per kg, divide by 78.12, something like this. So use all SI units. सभी को SI units ही use कर लो बच्चों. Then you will not face difficulty. Okay, if you are having difficulty in understanding, sir, what unit we need to use, like pressure in kilopascal or megapascal, forget all those things. Just use the SI units. Put pressure also in SI units. Put volume also in the SI units. Find out temperature also in SI units Kelvin. Okay, so don't say ki, sir, can I use it in megapascal? That unit you need to balance. Okay, it depends like how you are carrying out the calculation. This time I cannot say ki what calculation, like when you are carrying out the calculation, how you are putting all those units. So in that case, it is better to use the SI units. In all the cases, you can use SI units. Okay, I think this is very clear how to put pressure in SI units, how to put this HFG in SI units. Okay, joule per kg Kelvin. This also in joule per kg Kelvin. This is in Kelvin. This is in what, guys? Kg per meter cube. Okay, because this is the specific volume, so this will be in meter cube per kg. Meter cube per kg. This is in joule per kg. This is in Kelvin. This is in Newton per meter square. Then you will get delta T in delta T in Kelvin. Okay. So चलिए, let's move to next question, guys. Next question पे move करते हैं. Next 3-4 questions are comparatively easy. चलिए, प्लीज ट्राई टू आंसर दिस क्वेश्चन गाइस, प्लीज ट्राई टू आंसर दिस. Yes, please check your calculation guys. If you are not getting the answer, you need to check your calculation. 6.3 is the temperature difference you are going to get. Okay, so it is better to use all SI units so that you will get the answer. Next question in front of you. A substance is contained in a cylinder piston arrangement for certain time interval. The arrangement is heated and simultaneously the piston moves and does work. So there is some kind of positive work you are going to get because piston is moving and the piston is doing some kind of work. The initial state is 1 and the final stage is 2. Is asking you the correct statement. Very simple question guys, direct question. You know, piston substance contained in a closed piston cylinder arrangement, it is nothing but a closed system. A closed system. Mass in a piston cylinder arrangement is a closed system, and you know first law of thermodynamics for a closed system, dq equal to du plus dw. Okay, where q is the heat transfer from 1 to 2, u is the change in internal energy, means this you can write it as m into u2 minus u1 plus this is work transfer from 1 to 2. Why actually you can write this in like this? Because these are the exact differential. Internal energy is a property and it is the exact differential, but heat transfer, work transfer, these are not the properties and they are not exact differentials. So that these you cannot write it as q2 minus q1. इनको आप ऐसे नहीं लिख सकते. Writing q as q2 minus q1, work as w2 minus w1 is wrong actually, because these are not the properties, they are not the exact differentials. So if you match your answer, q1 to 2 w1 to 2 plus m u2 minus u1 means option b क्या हो जाएगा बच्चों? This is the right answer for this question. B is the right answer for this question. चलिए, let's move to next question. Question number 5. Again simple question है थोड़ा सा. Next 3-4 questions are comparatively direct and simple. Hot water flows into a long pipe. So this is a long pipe in which some kind of hot water is flowing. Water flow कर रहा है. Okay. By surrounding air, as shown in the figure, the temperature at the inlet is 80 degrees Celsius. So this is temperature at the inlet. Exit temperature is 50 degrees Celsius. Okay. So this is T1. This is T2. Long pipe which is cooled by surrounding air. इसको आप क्या कर रहे हो बच्चों? You are cooling it by surrounding air. So air is coming, it is taking heat, heat is taken by the air, so heat is lost by this water. Water temperature is decreasing and air is taking heat. He is asking you the entropy change of the system. So what you need to understand, he is not asking you entropy change of the universe. Entropy change of the universe in this case will be entropy change of system means water plus entropy change of the surrounding means air. Okay, so that will be always positive because this is also a irreversible process, so this will be always positive. But he is not asking you entropy change of the universe, means he is not asking you entropy generation, he is only asking you the entropy change of the water. As you can see, water temperature is decreasing, so entropy change of the water will be negative. Water ka entropy kya karega? It is going to decrease, so it will be less than 0. Okay, it will be less than 0. So you need to understand what he is asking you. He is asking you the entropy change of the system, he is asking you the entropy change of the surrounding. Okay, so for air the entropy change will be positive. For air the entropy change will be positive. Why? Because heat is going into the surrounding, so surrounding entropy is going to increase. Entropy change for the surrounding will be positive, entropy change for the water will be negative, and collectively if you will take the entropy change of system plus surrounding, that will be always positive. In any irreversible process, entropy change of the universe will always be positive. It always will be greater than equal to 0. Okay बच्चों, so for this question the right answer is option D. Okay, don't say B, B गलत हो जाएगा. B will be the wrong answer. I hope this is very much clear to you why I am saying B is wrong. He is not asking you entropy change of the universe guys, he is asking you entropy change of the system. System क्या है बच्चों? This is your system. Can you observe this symbol? So this is your system, this is your control volume. Water in, water out. So entropy change of the water, you know, entropy change of water means entropy change of your system is nothing but it is m dot cp, c for water, ln t2 by t1. Okay, as you know, like t2 is less than t1, so this will be negative. ये क्या आएगा आपका? नेगेटिव आएगा. For water the entropy is going to decrease. Got the point guys? Is that clear? ठीक है, so you need to observe very carefully what he is asking you. चलिए let's move to next question. Question number 6 in front of you guys. So there is a Carnot cycle shown in front of you. This is a Carnot cycle which is given. Which of the following statements are true for this Carnot cycle? So this is temperature versus entropy plot. Here you are having temperature, here you are having entropy. Temperature is in Kelvin, entropy is in kilojoule per kg Kelvin. Okay. So this diagram is given to you. Obviously, this is a diagram for a heat engine. किसके लिए diagram है? It is a kind of clockwise cycle. Okay. So clockwise है, so it is a kind of diagram Carnot cycle for a heat engine. So he's asking you the efficiency. आपसे क्या पूछ रहा है? Cycle efficiency पूछ रहा है, means efficiency of the heat engine, and he's asking you the W net. दो चीजें आपसे पूछ रहा है. Question is very simple. If you will go with very basic concepts, you will get the answer. So what is W net, guys? You know, W net is equal to Q net always. For any cyclic device, cyclic integration of heat equal to cyclic integration of work. This is first law of thermodynamics. We cannot create energy, we cannot destroy energy. The cyclic integration of heat equal to cyclic integration of work, or Q net equal to W net. Q net equal to W net. This is for any cycle, whether you are having a reversible cycle or irreversible cycle. This is true for both. Okay. So W net you want to find out, and this is equal to Q net, and Q net is nothing but the closed cycle area, because the area on the TS diagram is going to give you Q net. Okay, the closed cycle area on TS diagram is going to give you Q net. Okay, and Q net equal to W net. So this area you can write it as 7.42 minus 6.25 multiply by 15 minus 600. Okay, तो वर्क किस में आ जाएगा बच्चों? This work, because this is in kilojoule per kg Kelvin. This is in kilojoule per kg Kelvin. So work you are going to get in kilojoule per kg. वर्क किस में आ जाएगा आपका? किलोजूल पर केजी. टेल मी व्हाट वर्क यू आर गेटिंग इन किलोजूल पर केजी. What work you are getting in kilojoule per kg? Yes, W net equal to Q net, and Q net is a closed cycle area. Okay, how you will find the efficiency, guys? Efficiency क्या होता है? Efficiency is nothing but W net by heat supplied. W net by heat supplied. You know, guys, in this cycle, two processes are what? Reversible adiabatic. So in those two processes, there is no heat transfer. This is also reversible adiabatic process. This is also reversible adiabatic process. So in these two processes, there is no heat transfer. Heat transfer is there in two processes, this process and this process. You know, here entropy is increasing, means here you are adding the heat. So this is heat addition process. Here at constant temperature entropy is decreasing, means this is heat rejection process. Okay, this is heat rejection process. So the area under this entire curve is going to give you total heat addition. Area under this lower curve is going to give you the heat rejection. But here, this moment, we want heat addition. So the entire area under this. Okay. So entire area under this will be what? W net divided by the area of this entire rectangle. ये पूरा का पूरा area बच्चों. This complete area. This complete area. And how you will get the complete area, guys? This is the thing, but 7.42 minus 6.25 multiply by 1500 minus 0. So I'm writing it in only 1500. So this I'm assuming this is 0 Kelvin. So 1500 minus 0, this is the length. What you can say? This is the base. 7.42 minus 6.25 multiply by 1500. This is heat supplied. This is W net. W net you are going to get from this. तो यहाँ लिख भी सकते हो आप डायरेक्टली. This is 7. So ये टर्म कट जाएगी बच्चों. This is 7.42 minus 6.25 into 1500 minus 600, so it will be 900. Okay, divide by this same term. ये same term है. So this will cancel out. This will cancel out. So efficiency will be this. Efficiency of the heat engine will be 900 divided by 1500. So it will be 9 by 15 into 100. So you can check what answer you are getting. 3 पे करोगे, इसको 5 पे करोगे, so it will be 60%. Okay, so the efficiency will be 60%. Efficiency is 60%, and what W net you are getting, that also you can check. ठीक है बच्चों? So the question is very simple. Only some basic concepts, idea you need to have. Like if some kind of diagram is given to you, it is a TS diagram. Area under the TS diagram is going to give you the net heat transfer. Closed area on the PV diagram is going to give you the W. Okay, W net. PDV is not required here because there is no such PV diagram is given, but he has given you the TS diagram. So from TS diagram, you can find out Q net, and from first law of thermodynamics, you know Q net equal to W net. That's why I'm writing it here. W net equal to Q net. Q net we are obtaining from this diagram, and Q net is equal to W net. Go to the point, guys. So there is no need to find out PDV. PDV निकालने की जरूरत नहीं है बच्चों. Way to find the PDV. Is that clear, guys? So for this question, the right answer is ऑप्शन बी. ऑप्शन बी क्या हो जाएगा बच्चों? दिस इज द राइट आंसर फॉर दिस क्वेश्चन. एफिशिएंसी 60%, नेट वर्क आउटपुट 1053 किलो जूल पर केजी. आप देख भी सकते हो उसको. इफ यू विल मल्टीप्लाई दिस 900 मल्टीप्लाई बाय दिस, यू विल गेट दिस 1053 किलो जूल पर केजी. इज दैट क्लियर, गाइस? क्लियर है ये? यस. तो कैलकुलेशन मिस्टेक मत करो. बी वेरी क्लियर, अवेयर अबाउट ऑल दोस थिंग्स. नेक्स्ट क्वेश्चन में मूव करते हैं बच्चों. So this is next question in front of you. The system shown below is a tank with two inflows. दो inflows हैं. This is first inflow, this is second inflow. Which are steady. हालांकि ये word थोड़ा सा confusing है, steady, because this is not in steady state. ये steady state में नहीं है, because mass in is not equal to mass out. Mass in is not equal to mass out. ये steady नहीं है. This is unsteady state. Okay. He is mentioning they are steady. It means the at steady rate mass is entering, at steady rate this mass is entering here, and at steady rate the mass is going here, but the system is not in steady state. This control volume is not in steady state. You go to the point. So यहाँ पे जो steady का मतलब है, steady means this is entering at a constant rate, 10 kg per second. This rate is not changing. Inlet rate are not changing, exit rates are also not changing, those are constant. Okay, that is the meaning which we can get. So he's asking you, if density of the water is this, what is the rate of rise of the level inside the tank? What is the rate of rise of the level inside the tank? So cross-sectional area of the tank is given to you 4 square meter. Area of this tank is 4 meter square. Very simple question, guys. थोड़ा सा दिमाग लगाओगे, easily you will get the answer. He is asking you the rise in level of the water. So guys, you know what mass balance equation you can write it here? Mass in minus mass out equal to dm by dt of the control volume. You know, this is a mass balance equation we can write for any system in unsteady state. Mass in minus mass out equal to dm by dt of the control volume. This is the equation, guys, which we need to use it here. What is mass in? It is 10 plus 100. It is mass in. What is mass going out? It is 106. It is mass going out. So this is equal to dm by dt of the control volume. So d by dt of the control volume. Okay, right? Mass is equal to what? You know, density equal to mass per unit volume. So you can write mass equal to density into volume, guys. So you can write it as density into volume of the control volume. Yes or no? D by dt of the rho into V. You know, density of the water, which is constant, we can assume density constant. So density into dV by dt. Change in volume of the tank. Okay, so this is if you will solve it, it will be 4. ये कितना आ जाएगा? 4. So 4 equal to rho dV by dt. For the simplification, you can write it as 4 equal to the density of the water is given to you 1000 into d into volume. You can write it as area into x. Okay, area into x. D into area into x. Yes or no, guys? So area also, area for this tank is constant. Area भी क्या है बच्चों? Constant है. So you can write it as 4 equal to 1000 into 4, because area is 4 into dx by dt. What is dx by dt, guys? It is a change in level of the water inside the tank. This dx by dt is nothing but a change of water level in the tank. Change of water level in tank. At what rate the water level is changing in the tank? So this will cancel out. So dx by dt will be 1 by 1000. So it will be 10 की power minus 3 meter per second. 10 की power minus 3 meter per second. So if you will convert it in mm, you can write it as 1 mm per second. So the rate of change of the level of the tank is 1 mm per second. 1 mm per second. Okay, so option A क्या हो जाएगा बच्चों? This will be the right answer for this question. The rate of change of level inside the tank is 1 mm per second. You got the idea, guys? The rate of change of level inside the tank is 1 mm per second. चलिए लेट्स मूव टू नेक्स्ट क्वेश्चन. So this is a kind of MSQ question, multiple select question. Multiple select questions है बच्चों. तो let me put it here in front of you. I hope this is visible to you. So what is saying, which of the following statements are not correct? इनमें से कौन सा statement correct नहीं है? So 4 statements are given to you. He is asking you which of the following statements are not correct. Simple question है बच्चों. From very basic concepts you can solve this question. 1 mm per second. Yes. So he's asking you ACD obeys first law of thermodynamics, closest inequality. So means if you will observe the options, he's asking you out of these 4 diagrams, like this is a diagram for a heat engine, all are the diagram for a heat engine because all are work producing systems. He's asking you A, B, C, D. These are the 4 heat engines. Which each heat engine is not following first law and second law? Yeah, all are following first law or second law. You need to check. So you need to check individually first law and second law for all these. फर्स्ट लॉ और सेकंड लॉ आपको हर इंजन के लिए चेक करना पड़ेगा बच्चों. सो हाउ टू चेक द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स फॉर फर्स्ट इंजन? फर्स्ट लॉ का मतलब क्या है बच्चों? व्हाट डू यू अंडरस्टैंड बाय फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स? साइक्लिक इंटीग्रेशन ऑफ हीट इक्वल टू साइक्लिक इंटीग्रेशन ऑफ वर्क मींस नेट हीट ट्रांसफर equal to net work transfer. So you can check it here. What is net heat transfer? 1000 addition equal to 600 plus this is also rejection. तो आप इसको ऐसा लिख सकते हो, net heat transfer is 1000 addition minus 600 equal to 400. So it is satisfying first law of thermodynamics. तो first को तो ये satisfy कर रहा है. First this law is satisfying. This diagram, this first heat engine is satisfying first law. This also if you'll observe 3000 minus 100 minus 2900. So this is also satisfying first law of thermodynamics. Okay. If you will check for third, 100 minus 90, 100 minus 90 kilowatt. This is in kilowatt, this is in kilowatt. But the work is in 10 megawatt, means it is not satisfying first law. Not satisfying first law. Here, 100 kilowatt is a heat input, 90 kilowatt is a rejection. So the work output will be 10 kilowatt. ये होना कितना चाहिए था? 10 kilowatt. But here it is given 10 megawatt, means it is not satisfying first law of thermodynamics. Here if you will check 10 megawatt, 8 megawatt means work output is 2 megawatt. So this also is satisfying first law. So out of these 4, A, B, C, D, these 3 are satisfying first law. A, B, D all are satisfying first law. Now you can check the second law also, guys. For second law, you need to check the closest inequality. Second law के लिए आपको क्या चेक करना पड़ेगा? Closest inequality. Cyclic integration dq by t. If it is less than equal to 0, it's fine. If it is greater than equal to 0, greater than 0, then that it is violating. It is a violation of the second law of thermodynamics because it is not possible for any device to have cyclic integration dq by t positive. So dq by t will always be less than equal to 0. If it is less than 0, means that device is the irreversible device. If it is equal to 0, means that device is the reversible one. Greater than 0 is impossible. That is a violation of second law of thermodynamics. So you can check it here. दोनों के लिए चेक कर लो, इसके लिए चेक कर लो. If you will check it here, 1000 means 1000 divided by 1000. This is addition, so it will be positive. Minus 600 divided by what? 400. So this is positive, this is negative, this and this value is more. So this is less than 0. You can easily comment yes or no. 1000 by 1000 minus 600 by 400. This is negative, so this is satisfying second law also. ये second को भी क्या कर रहा है? Satisfy कर रहा है. You here also you can check 3000 divided by 6000 minus 100 divided by this 300. Okay, 3000 divided by 600 minus 100 divided by 300. Okay, तो इसको चेक करोगे बच्चों, ये क्या हो जाएगा? This will cancel out. You will get 0.5. 0.5. Okay, किस में आएगा? It will be in kilowatt per Kelvin. This is in kilowatt per Kelvin. अभी ये क्या हो रहा है? This is coming out more than 0. Because this is in 3000 kilowatt, 3000 by 600 minus 100 divided by 300. This is coming out greater than 0. Yes or no, guys? This is coming out positive. So this is the violation of second law of thermodynamics. This is the violation of second law of thermodynamics. So the diagram B is not satisfying second law of thermodynamics. So this is violating the second law. Yes or no, guys? Okay. Same with this. You can check. आप यहाँ पे भी check कर सकते हो. इसके लिए भी चेक कर सकते हो 100 डिवाइड बाय 300 माइनस 90 डिवाइड बाय 270 100 डिवाइड बाय 300 माइनस 90 डिवाइड बाय 270 ओके तो ये तो कट ही जाएगा तो 1/3 सो इट इज कमिंग आउट 0 दिस इज आल्सो नोट द वायलेशन ये सेकंड को वायलेट नहीं कर रहा है दिस इज सेटिस्फाइंग सेकंड लो बट ये फर्स्ट को वायलेट कर रहा था दिस इज सेटिस्फाइंग सेकंड लो बट वायलेटिंग द फर्स्ट लो सेम विद दिस आल्सो यू कैन चेक इसके लिए भी चेक कर सकते हो 10 डिवाइड बाय this 400 minus 8 divided by this is 47 तो 47 plus 273 करोगे it will be 280 plus 40 280 plus 40 it will be 320 okay so अगर आप इसको भी चेक करोगे आप you can check because this is 1/40 and this is 8/40 so again it will come out 0 ये भी क्या आ जाएगा बच्चों this will come out 0 so this is also not the violation this is also satisfying fourth law second law of thermodynamics so guys what we concluded first is satisfying out of these four first second and this last D they all are satisfying first law this C is not satisfying first law okay A B and D they all are satisfying second law but the C is not satisfying the this second law of thermodynamics okay तो ये हम इससे कंक्लूजन निकाल दिया है and then if you will answer A, C and D all are satisfying the first law of thermodynamics because this ये आपने guys when we checked that B is not satisfying okay only A, C, D obeys the first law and also the closest inequality you can check guys A, C, D because this is not yes B तो नहीं किया but इसके लिए फर्स्ट लॉ भी चेक कर लेते हैं तो 100 माइनस दिस तो मतलब क्या है यहाँ पे ये तभी होगा अगर इफ यू विल एज्यूम दिस इज दी व्हाट ये अगर 10 किलोवाट होगा लेट्स सी इफ देयर इज एनी अदर ऑप्शन ए डी डू नॉट वायलेट फर्स्ट लॉ एंड क्लोजेस्ट इनइक्वालिटी सी वायलेट्स फर्स्ट लॉ सी क्या कर रहा है फर्स्ट को वायलेट कर रहा है बी वायलेट्स क्लोजेस्ट इनइक्वालिटी सो आई थिंक दिस इज द राइट आंसर गाइस सी क्या कर रहा है सी इज वायलेटिंग द फर्स्ट लॉ and B is violating the closest inequality. Option C is the right answer for this question. D is the reversible cycle and A is an irreversible cycle. Okay, तो ये भी सही है because this is a MSQ question. This is a MSQ question, guys. Multiple select question. D is reversible. D reversible है बिल्कुल. How you can say this is 10/40. 10/40. अच्छा 10/40 है हाँ yes. So this is 1/40 and this is 8/320. So this is 1/4. ये गलत हो जाएगा ना ये गलत हो जाएगा because this you need to check this is 10/400 minus 8 divided by 320 okay so this is 1/40 because initially I thought this is 1/4 so this is 1/40 minus 1 by हाँ ये भी 1/40 है तो ठीक है this is a reversible cycle okay this is equal to 0 means this is a reversible cycle 8/320 this is equal to 0 means this is a reversible cycle okay so this is actually MSQ question multiple select question is asking you the multiple select question D is a reversible cycle A is a irreversible why because this is less than 0 what I told you guys what idea you need to have what you need to remember cyclic integration dq by t less than equal to 0 if it is equal to 0 means the device is reversible this is for reversible if it is less than 0 means the device is irreversible okay if it is greater than 0 this is the violation of second law of thermodynamics this is violation of second law of thermodynamics so indirectly he has given you the 4 diagrams and he is asking you the multiple questions from this because this is actually a question MSQ questions which you need to answer ओके थोड़ा सा टाइम लगेगा बिकॉज एमएसक्यू क्वेश्चन में 2 नंबर वो आपको तभी देता है बच्चों दिस क्वेश्चन आई पिक्ड फ्रॉम द एनपीटीईएल असाइनमेंट और ये इतना पुराना क्वेश्चन है लाइक आई थिंक दिस इज फ्रॉम द ईयर 2019 व्हेन दे हैव नॉट एक्चुअली स्टार्टेड दोस आस्किंग दोस टाइप ऑफ क्वेश्चंस एमएसक्यू ओके सो यू कैन आंसर दिस क्वेश्चन ए सी डी अगर हम इस डेटा के साथ जाते हैं ए सी डी ओबेज फर्स्ट लॉ हमारा तो सी नहीं कर रहा था तो हम इसके साथ नहीं जाएंगे ओके बिकॉज इफ यू विल एज्यूम कि एवरी डेटा इज राइट सो दिस इज नॉट राइट AD do not violate first law and closest inequality ये भी ठीक हो जाएगा AD violate तो नहीं कर रहे हैं फर्स्ट लॉ को violate नहीं कर रहे हैं and they are also not violating the closest inequality. C violates first law and B violates closest inequality. D is reversible and A is irreversible. So these three are the right option. And in MSQ question, you need to select this. There must be some kind of option, something like this. So you can select any one or you can select any all. Okay. So here you need to select this. Then only you are going to get the answer for this question. Is that clear, guys? Okay, there must be some more options. Okay, this is actually a MSQ question. So don't say कि sir C is the right answer or A is the right answer. You are going to get multiple answers for this question, guys. इस questions के लिए आपको multiple answers मिलने वाले हैं. ठीक है, multiple answers. But अगर वो आपसे पूछे, like let me check because he asked you which of the following statement is not correct. Okay, मैंने इसको MSQ बना दिया actually. I framed it like the MSQ, but which of the following statement is not correct? So कौन सा correct नहीं है बच्चों? Which of the following statement is not correct? अगर आप MSQ बनाते हो, in MSQ question, MSQ में you need to answer B, C, D because all are right. अगर मैं इस क्वेश्चन के हिसाब से जाऊं, which is not right? Not right. कौन सी statement right नहीं है बच्चों? A is not right. Okay. So if you are saying answer A, sir, statement A is not right, then also it is fine. And if you are saying, sir, for MSQ, statement B, C, D are right, then also it is right. Got the idea, guys? So if you will check the data here, we have concluded this is satisfying both first and second. This is not satisfying second. This is not satisfying first. And this is satisfying both first and second. And this is a reversible cycle. So from that, we have concluded, we framed it like initially MSQ, multiple select questions. So all statements B, C, D are right, A is not right. Okay, but initially because they asked this question something like that, I thought it like a MSQ, and it is good to frame this question like MSQ. Okay, because there is a high probability of asking this type of question. बहुत confusing हो जाएगा, and lots of students they will do those kind of mistakes. Okay, so in MSQ it's a very good question. 3 options you need to answer, B, C and D. Statement A is not right. अगर आप इसको simple question बनाते हो, multiple choice question, MCQ, for MCQ you can go with option A because option A, statement A is not correct. Okay, statement A क्या है वो correct नहीं है. Okay, they mentioned statement A as the right answer. Only statement A, C, D obeys first law of thermodynamics. This statement is not right. This is not right. Got the idea, guys? So I discussed this question in both the ways, in NCQ manner and in MSQ manner. Is that fine, guys? ये clear है आपको? Yes. Please check this question again. Tell me, is that clear? Yes, guys. Please tell me, is that clear? Manoguma ready? You need to check. Why you are saying C? Yes, guys. Please confirm. चलिए, let us now move to next question, guys. Next question में move करते हैं. Question number 9. Don't worry about the data, guys. Question देख के मत डरना. Question is very simple, easy. So there is a tank capacity 2 meter cube contains ammonia at 3 bar 350 Kelvin. Another tank's B capacity 1 meter cube contains ammonia 1.2 bar 50% quality. Both tanks are perfectly insulated. So the problem is something like this. दो tank है. So there is this tank A. This is tank A. This is tank B. Okay, this is tank B, something like this. Okay, these are connected with some kind of valve. So this is tank A, this is tank A, this is tank B. This is having volume 2 meter cube. Okay, this is having volume 1 meter cube. इसका volume कितना है? 1 meter cube. This is having volume 2 meter cube. This is containing ammonia at 3 bar 350 Kelvin. Okay, and another tank which is having volume 1 meter cube, it is containing ammonia at 1.2 bar 50% quality. 50% quality. Quality means 50% means dryness fraction is 0.5. The dryness fraction in the tank B is 0.5. The tanks are connected with the pipe which is having a valve installed. So this is the valve through which these tanks are connected. The valve is initially closed. Initially it is closed. Okay, so if you open the valve such that these two masses, they will come in equilibrium. Okay, and the final state of the two independent properties are desired. So what he is asking, guys, final stage पूछ रहा है आपसे, like after opening this valve, if you will open this valve, is asking you the final enthalpies, is asking you the final volume, is asking you the final temperature. So after opening this valve, what is the final enthalpy, what is the final specific volume? Okay, something like this. These data he is asking you. So the problem is very simple, guys. Only you need to be very clear about the mixing process. It's a case of mixing, guys. This is a case of mixing. You know, in mixing, what is the enthalpy final? How you can write the energy balance? Energy balance कैसे लिख सकते हैं बच्चों? How you can write the energy balance for the mixing process? So energy balance for the mixing process is nothing but M1 H1 plus M2 H2. This is equal to M3, yeah, M final H final. M final H final. Yes or no? So this is the energy balance equation. M1 H1 here, M1 H2 here. Here directly is giving you because here you are having the superheated ammonia. यहाँ पे आपके पास क्या है? Superheated ammonia, and at 3 bar 350 Kelvin, the superheated ammonia is having this much volume, this much enthalpy. So here he is directly given you H1. मैं अगर यहाँ लिखूं, so this is H1, guys. This is nothing but H1. This is nothing but V1. ओके इसको इफ यू विल मल्टीप्लाई बाय इफ यू विल आप इसको क्या करोगे द वॉल्यूम इफ यू विल डिवाइडेड बाय दिस तो आपके पास मास आ जाएगा यू विल गेट m1 फ्रॉम वेयर यू आर गोइंग टू गेट द m1 सो m1 mass in the container 1 is nothing but the volume of the container 1 which is 2 meter cube divided by this specific volume 0.5591 you will get m1 आपके पास क्या आ जाएगा बच्चों m1 okay h1 is directly given to you s is also given to you. How to find out entropy here? H2 कहां से आएगा बच्चों? H2. So H2 you will get HF plus XHFG because in the tank 2 you are having a mixture of saturated ammonia plus saturated vapor. Okay, so you are having a wet mixture which is having dryness fraction quality 0.5. So H2 enthalpy of the ammonia in the tank 2 is nothing but HF plus 0.5 into HFG. So these data are also given to you. You need not to worry because at 1.2 bar saturated temperature is this. This is the T saturation. This is VF. This is VG. This is HF. This is HG. This is SF, SG. So easily you will get enthalpy here. Yes or no, guys? यहाँ पे enthalpy आ जाएगी. Yes or no? You will easily get the enthalpy in the tank 2. Tank 2 में आपके पास क्या आ जाएगी? Enthalpy आ जाएगी. Same with the specific volume. You can easily get specific volume in the tank 2. V2 equal to Vf plus X VFG. Yes or no? From this you will get V2. Okay, and what you need to do if you want to find out M2 mass in the tank 2, so what you need to do? You need to divide volume of the tank 2 divided by specific volume of the tank 2. Volume of the tank 2 is given to you, which is nothing but 1 meter cube. Okay, 1 meter cube, if you will divide it by V2, you will get M2 also. So M1 will be easily known to you. M1 भी बड़ी easily आपके पास आ जाएगा. Easily you will get M1. H1 is directly given to you. M2 you will get from this data. H2 also you will get from this analysis. M final is nothing but M1 plus M2. Yes or no? So easily you will get the enthalpy final. So can you tell me, guys, what enthalpy final you are getting, guys? Now can you tell me, guys, what is the final enthalpy you are getting for this question? Let me put it here again. This question in front of you. The question is very good, guys. बहुत अच्छा question है. It is looking like very difficult question, but the question is not difficult. Question is very easy. So he has given you two tanks. This is tank 1. This is tank 2. They are connected with some kind of pipe through a valve. The valve is initially closed. The tank A is having volume 2 meter cube, pressure 3 bar, 350 Kelvin, containing saturated ammonia. Containing superheated ammonia. Tank 2 containing mixture, wet ammonia with quality 0.5. 50% at a pressure 1.2 bar, volume 1 meter cube. So from that easily, because if you know the quality, you can easily find out H2, HF plus XHFG, V2 equal to VF plus XVFG. Okay, तो इसको बताओ मेरे को, एनालिसिस करो एंड टेल मी व्हाट फाइनल एंथैल्पी यू आर गेटिंग. एंड गाइस इफ यू नो द फाइनल मास, अगर आपके पास मास फाइनल आ गया है, सो द फाइनल मास इज नथिंग बट m1 plus n2. सो कैन यू टेल मी द फाइनल स्पेसिफिक वॉल्यूम? Can you tell me the final specific volume, guys? So final specific volume is nothing but the final volume divided by the final mass. The final specific volume is nothing but final volume divided by final mass. What is final volume, guys? Because if you open the valve, the final volume become 2 plus 1 3 meter cube. So the final volume is 3 meter cube. Okay, 3 meter cube. This 3 meter cube, if you will divide it by mass final is nothing but m1 plus m2. So this also you know, this is the final volume, you know. Solving this easily, you will get the final specific volume. So guys, can you tell me what final specific volume you are getting, what final enthalpy you are getting, and based on that can you answer out of these 4 options? Can you answer anyone, guys? क्या इन 4 ऑप्शन में से कुछ को आंसर कर सकते हो? What is the final specific volume you are getting, and what is the final enthalpy you are getting? तो क्वेश्चन इज वेरी गुड गाइस. ओके, बहुत अच्छा क्वेश्चन है. मिक्सिंग में हाउ टू फाइंड आउट द फाइनल एंथैल्पी, हाउ टू फाइंड आउट द masses in tank 1, tank 2, final masses also, and final specific volume. Okay, so please tell me guys the answer out of these options A, B, C, D. What answer you are getting? What is the final specific volume and what is the final enthalpy? जल्दी से बताओ बच्चों. Please carry out the calculation quickly and tell me what final enthalpy and final specific volume you are getting. देखो बच्चों, you know here the temperature is 350, here the saturation temperature is 243. यहाँ पे saturation temperature कितना है? 243.24 Kelvin. Here temperature is 350, here temperature is 243.24. So final temperature will be somewhere in between these two temperatures. Yes or no? Final temperature कुछ इन दोनों के बीच में होना चाहिए. Is it possible to have a final temperature 350 Kelvin only? No. If these are mixing, the final temperature will be in between this and this. Okay. Final temperature क्या होगा? उन दोनों के बीच में होगा. Although you can find out that exact value because आपके पास मिक्सचर की क्वालिटी आ जाएगी, कितना मासेस यहाँ पे मिक्स हो रहा है. Because entropy also, if you will find out, based on that you will be easily able to calculate. But from our own understanding, because these things, two things easily you will be able to calculate: the final enthalpy and the final specific volume. And two more very important conclusion you can make: the final temperature will be in between this and this. So this statement is not right. C is not right. Final temperature 350, this is not right. Final pressure is also will not be also equal to 3 bar. ये भी 3 bar नहीं हो सकता बच्चों. This is also not 3 bar. Why? Because this is in 3 bar, this is at a pressure 3 bar, this is at a pressure 1.2 bar. So how you can have a final pressure 3 bar only? So final, because from external there is no such heat transfer. बाहर से तो कोई heat transfer नहीं हो रहा है. Volume is increasing, so there must be some kind of change in pressure here. So this statement is also not right. Okay. And here if you will solve, अगर आप इसको solve करते हैं बच्चों, enthalpy you will get, and that also you're not going to get this. Final enthalpy आपका ये नहीं आएगा. Final enthalpy will not come out this. So then also you can make your judgment कि sir this is also not right. So if you will solve, you are going to get final specific volume this. एक तो आपका final specific volume ये आ जाएगा. This is a final specific volume you are going to get. Final enthalpy also you are going to get. यहाँ से आपका final enthalpy आएगा. You can calculate what final enthalpy you are getting. So when I calculated, I got the answer 1444.384 kilojoule per kg. जब मैंने कैलकुलेट किया था बच्चों, I got the answer this. Final enthalpy is 144.384. So which is also not there in option 1. Okay, and in option D, he has not mentioned enthalpy, he has mentioned the internal energy only. So from this entire analysis, we can conclude only option D is right, and this is the right answer for this. Otherwise, if you want to calculate the internal energy, so you need to go with some more analysis. With this, you need to write, H equal to U plus PV. Okay, so U equal to H minus PV. Okay, So final internal energy you need to calculate. Final internal energy you need to calculate if you know the final pressure and if you know the final volume. Final volume we know. For that you need to calculate the final pressure also. So final pressure, final volume. So इसमें से घटाओगे this is final enthalpy we are getting 1444. If you subtract this, definitely you are going to get this answer close to this 1316.68. Okay, but otherwise if you will check your options, the specific volume, final enthalpy, then also easily you will be able to make the conclusion option D is the right answer for this question. Please tell me guys, is that clear? How actually I'm answering option D as the right answer for this question? Please confirm. Is that clear guys? How we can answer option D as the right answer? Because we calculated the final enthalpy and we are getting the final enthalpy which is not equal to 1316, so we can make the judgment option A is not right. Similarly, option B is not right because final pressure is going to change, final temperature is also going to change. You can calculate, otherwise the question will become much more lengthy. Okay, and the enthalpy, final enthalpy you are going to get, final enthalpy you will get, which is 1444.384. If you want to find out the final internal energy, okay, final internal energy, then you need to subtract the flow work PV from that, from the enthalpy. So final pressure you need to calculate. Final pressure आपको calculate करना पड़ेगा बच्चों. For that you need to calculate the final pressure. ठीक है? And in that case guys, because there is no such other data is given. Yes, Manoguma, now you are answering right. 1444, something like that. That is right for the final enthalpy. The final enthalpy will be in the range of 1444. This is right. Okay. Directly finding the final pressure is not that much easy because you are not having superheated gas both sides. यहाँ पे आपके पास superheated नहीं है बच्चों. This is superheated ammonia, but this is your saturated ammonia. Okay, masses you know, and this like mixing process fully insulated है, so entropy change of the surrounding will be zero. This is fully insulated, so entropy change of the surrounding will be zero. Entropy change surrounding का क्या हो जाएगा बच्चों? It will be zero. So energy balance we applied, based on that we calculated the final enthalpy. Entropy balance भी आप यहाँ पे लगा सकते हो. Entropy भी आप देख सकते हो because entropy change for this, entropy change for this. Okay. Final temperature, you need to calculate the final temperature, you need to calculate the final pressure, which you are not going to get directly. Okay, so here you need to make the judgment based on your data which you calculated, the specific volume and the enthalpy which we have calculated. ठीक है बच्चों? Because it is not directly, you will not be able to calculate those internal energy, final temperature and final pressure, because these are not like the mixture of ideal gases. You cannot write it as here PV equal to MRT, something like that. P initial, P1, V initial equal to M initial or T initial, something like that. You cannot use those equations. Here you can use because this is superheated ammonia, but here you will not be able to use. तो दो इक्वेशन आप यहाँ पे लगा सकते हो, जो आपको यहाँ पे लगा के आप ट्राई कर सकते हो. What are the two equation guys? M1 plus M2, this is equal to M final. This is first equation. V1 plus V2, this is equal to V final. Okay, तो यहाँ पे इसी इन दो इक्वेशंस को लगा के आप यूज कर सकते हैं. थर्ड वन इज M1H1 plus M2H2 equal to M final H final. Okay, these are the three equations which we are having: mass, volume, and energy. Okay, based on these three equations, you can try to find out. चलिए, but otherwise it is very easy, simple to answer this question. Option D, if you have calculated the final specific volume and final enthalpy. So you need to have an idea how to calculate final enthalpy and final specific volume in these kind of cases. So next question guys in front of you, question number 10. The final temperature of a sample of argon 12 gram that is expanded reversibly and adiabatically 1 decimeter cube to 273.15 Kelvin to 3 decimeter cube. Okay, he's asking the final temperature. Both simple question है बच्चों. Please try to answer. All of you who are watching this lecture, this is very simple question guys, and you need to answer each and every one of you need to answer guys these type of question. So this process is reversible adiabatic. reversible adiabatic process. You know guys, for a reversible adiabatic process and the expansion of argon, ये बस ध्यान रखना, you are not expanding air, you are expanding argon. So for reversible adiabatic process, you are having the relationship T2 by T1 equal to V1 by V2 power gamma minus 1. This is the relationship, guys. You know this relationship, this one you need to remember, T2 by T1 equal to P2 by P1 power gamma minus 1 by gamma equal to V1 by V2 power gamma minus 1. This is the more important relationship, guys, which you need to remember. Based on that, you will be able to write the relationship between temperature, pressure, temperature, volume. Here we want the relationship between temperature and volume. So T2 we want to find out, T2 equal to T1. T1 is nothing but initial temperature 273.15. The initial volume is 1 decimeter cube. So this is 1 decimeter cube. There is no need to convert the units because these are in ratio, so unit will be easily balanced. 273, 1 decimeter cube divided by 3 decimeter cube, V1 by V2. But here, what is gamma, guys? Gamma for monatomic gases. Like argon, it is 1.67. So don't take it as 1.4. अगर आप 1.4 लोगे, you will get the wrong answer. Don't take gamma 1.4. You need to take gamma 1.67. Gamma for monatomic gases like helium, argon, neon. For these type of monatomic gases, gamma will be 1.67. So here you will have 0.67. Okay, T2 equal to 273.15 power 0.6. Okay, solving this, you will get the answer which is close to 131 Kelvin. So question is very simple. Two things you need to remember. What is the relationship for the between the temperature and volume for the reversible adiabatic process? This is the first thing you need to remember. Second, what is the gamma value for monoatomic gases? Gamma value for monoatomic gases. If you are clear with these two things, then easily you will get the answer. ठीक है बच्चों? Let us move to next question, question number 11. So this is next question, question number 11. A sample of carbon dioxide. So there is a sample of carbon dioxide which is having mass 2.4 grams at 27 degrees Celsius is allowed to expand reversibly and adiabatically. So the expansion is reversible and adiabatic, means reversible adiabatic expansion you are having from this volume. So this is initial volume 500 centimeter cube and this is final volume 3 decimeter cube. He is asking you the work in this case. What is the work in this case? What is the work done or on the gas in this case? How to find out work transfer in this case, guys? As clearly as mentioned, the process is reversible adiabatic, so the work will be P1V1 minus P2V2 by gamma minus 1. Gamma is 1.29 for carbon dioxide, like exhaust gases. We can take it close to 1.28, sometime 1.3 also. So for carbon dioxide, gamma is 1.29. Okay, so don't use gamma 1.4. You need to use gamma 1.29. Okay. Pressures we don't know. We don't know the volume only. अपने को क्या पता है? Volume पता है. Temperature pata hai, we know the temperatures also. So this expression you can write it something like this, assuming the ideal gas behavior, this you can write it as mr T1 minus T2 divided by gamma minus 1. Yes or no? आप इसको ऐसा भी लिख सकते हो, because P1V1 equal to mRT1, P2V2 equal to mRT2. mR is constant, mR you can take it outside, mR into T1 minus T2 divided by gamma minus 1. So what is the mass, guys? Mass is 2.4 gram, so 2.45 into 10 to the power minus 3. This is mass. What is R? For carbon dioxide, R is nothing but 8.314 divided by 44. Universal gas constant, characteristic gas constant, guys. Characteristic gas constant is nothing but a universal gas constant divided by molecular weight. This is very simple direct relationship which you need to remember. The characteristic gas constant equal to universal gas constant divided by the molecular weight. So this is mass 2.45. We converted into what? Kg, because SI units you need to use. This is mass in kg. This is characteristic gas constant 8.314 divided by 44. T1 is 27 degrees Celsius, so it is 300 Kelvin. T2 we don't know this time, but we can easily find out from the relationship. Gamma minus 1 means this is 0.29. Okay, 0.29. T2 कहां से आएगा बच्चों? From where you are going to get the T2? T2 कहां से आएगा? For T2 you can write this relationship T2 by T1 is equal to V1 by V2 power gamma minus 1. What is V1 guys? V1 is 500 centimeter cube. So 500 centimeter you need to convert into decimeter. सेंटीमीटर को क्या बनाना पड़ेगा आपको? डेसीमीटर बनाना पड़ेगा. ओके, यू नो हाउ मेनी डेसीमीटर्स आर देयर इन 1 सेंटीमीटर? 10 की पावर -1. यूनिट्स क्या है? सेंटीमीटर इज अ लोअर यूनिट. सेंटीमीटर, डेसीमीटर, मीटर. हाउ मेनी मीटर्स इन 1 सेंटीमीटर? 10 की पावर -2. How many decimeters in 1 centimeter? 10 की पावर -1. Okay, so here 500 multiplied by 10 की पावर -2 decimeter cube. तो 10 की पावर -2 है ना, 10 की पावर -1 है, तो 10 की पावर -1 क्यूब इफ यू विल टेक, you will write it here 10 की पावर -3. Okay, because 1 centimeter is equal to 10 की पावर -1 decimeter. So 1 centimeter cube equal to 10 की पावर -3 decimeter cube. Okay, divide by 3 decimeter cube, power 0.29. Power 0.29. Why? Because gamma is 1.29 for carbon dioxide. So इसको solve करोगे you will get the T2. Solving this you will get the T2. Yes or no guys? Solving this you will get the T2. Okay, but we will try to share the link to download the workbook. Okay, you need to wait. Surely soon we will share the link in this link in this comment section only. You will find the link. Okay, chaliye. So guys, tell me what answer you are getting. Work we want to find out. We are interested in finding out this work. 2.45 multiplied by 10 की power -3 into 8.314 divided by 44 multiplied by 300 minus 32 divided by this. So tell me the work. What work you are getting? Now can you tell me the answer guys? Please give me the answer. Please give me the answer guys for this question. What you are getting as the answer? Yes, only you need to put the given data. Mass is given to us. Mass is given to us in grams, so we converted it into kg. Characteristic gas constant is nothing but universal gas constant divided by molecular weight. For carbon dioxide, the molecular weight is 44. You know, carbon dioxide is what? CO2. So for oxygen, it will be 32. For carbon, it will be 12. So 12 plus 32, you will have molecular weight for the carbon close to 44. So universal gas constant, you need to divide by 44 to get the characteristic gas constant for carbon dioxide. Multiply by T1 minus T2. T1 is known to us 300. T2 we obtained from the relationship given. Divided by gamma minus 1. Gamma is given to us 1.29. Solving this, you will get answer 194. Actually, you are going to get positive work. आपको इसमें क्या मिलेगा? Positive work मिलेगा. Because this is expansion process. Positive work मिलेगा 194 joule. Okay. But actually they mentioned, यहाँ पे उन्होंने कुछ ऐसा mention किया था, what is the work done on या by the gas. So then you can answer this also. B को आप क्या कर सकते हो? Answer कर सकते हो. Negative sign is representing only the work done on, because actually you are having the work done by the gas. So work done by the gas is 194, or work done on the gas will be minus 194. So minus is representing there is no work done on the gas. Minus sign means work is done by the gas. तो ये यहाँ पे मिस्टेक थी. That's why I corrected it here. मैंने यहाँ पे लिख दिया था by या on. They mentioned it here, work done by the gas, and they answered this minus 194. So they are saying here what is the work done by the gas also, and they are answering 194, which is actually wrong. Okay, that's why I mentioned it here, work done on the gas. So work done on the gas is minus 194. Got the point guys? So answer you are going to get 194. Okay, so if they are asking you what is the work done by the gas, work done by the gas will be 194 positive, because gas is expanding, so the work done will be positive. But if they will ask you what is the work done on the gas, so work done on the gas will be negative, minus 194. Chaliye. And what is the magnitude of work done guys? The magnitude of work done will be 194 only. Chaliye. Let us move to next question. Question number 12. There is a sample consisting of 1 mole of argon expanded isothermally at 0 degree Celsius from 22.4 decimeter cube to 44.8 decimeter cube reversibly. Okay, ऑप्शन ए रिवर्सिबली, ऑप्शन ए में पूछ रहा है रिवर्सिबली. सेकंड ऑप्शन पूछ रहा है अगेंस्ट ए कांस्टेंट एक्सटर्नल प्रेशर equal to the final pressure of the gas. In third case, he is saying gas is expanding against vacuum. So in all these three cases, what will the work? W1, W2, W3. So W3 work in free expansion, which is actually 0. There is no need to calculate. Work done in the free expansion. Work done in first case, temperature constant, isothermally. Reversibly and isothermally. Reversibly and isothermally. Isothermally from 0 degree Celsius, reversibly. Second case, he is saying against a constant external pressure equal to final pressure of the gas. So this is actually kind of final constant pressure process. So in these three cases, he is asking you the work, and based on that, you need to answer. Based on that, you need to answer, guys. So he asked you the work for the expansion of gas. Argon is expanding. The mass of the argon is 1 mole. Okay. And he's saying the gas is expanding from 0 degree Celsius from volume 22.4 decimeter cube to the final volume 44.8 decimeter cube. In first option, he's saying, in first part, he's asking you if the gas is going to expand reversibly isothermally. Second case, he's asking you if the gas is going to expand at a constant pressure. In third case, he's asking you if it is expanding freely, means expanding against vacuum, because he's saying freely means it is expansion against external zero pressure. So it is a kind of free expansion. तो बेस्ड ऑन दैट ओनली डायरेक्टली तो आप आंसर कर सकते हो इसको कि सर ना तो ये आंसर हो सकता, ना ही ये हो सकता, ना ही ये हो सकता, तो आंसर तो ए ही होगा. बट यू कैन कैलकुलेट ऑल्सो, आप इसको कैलकुलेट भी कर सकते हो. ओके, you need to calculate this also, guys. ठीक है. So if you will calculate constant temperature, क्या होता है? What is the work transfer in constant temperature process? It is nothing but mr t ln v2 by v1. On mass basis you can write it something like this. मास बेसिस पे आप इसको ऐसा लिख सकते हो. बट इफ यू आर हैविंग मोल, अगर आपके पास मोल है, सो यू कैन राइट इट एज n r bar t ln v2 by v1. आप ऐसे भी लिख सकते हो बच्चों. Okay, this you need to remember. If you are writing it on the mass basis, mRT ln v2 by v1, where m is the mass of the gas, r is the characteristic gas constant, t is the temperature, constant temperature, ln of v2 by v1. But if you are not having mass, you are having number of moles, so you can write it as n r bar t ln v2 by v1. Why? Because sir, m equal to nm, m equal to nm. तो अगर आप यहाँ पे nm लिखोगे तो क्या हो जाएगा? Characteristic gas constant into molecular weight, this will become universal gas constant and will remain n only. So you will get this. Mass equal to product of number of moles into molecular weight. ठीक है, तो नंबर ऑफ मोल्स आपको दिए हैं बच्चों, नंबर ऑफ मोल्स उसने दिया है आपको. नंबर ऑफ मोल्स कितने हैं? 1 है. नंबर ऑफ मोल्स आर 1, तो 1 into 8.314 जूल पर मोल केल्विन. ये जूल पर मोल केल्विन हो जाएगा. दिस इज इन मोल, ये 1 मोल है तो इसको जूल पर मोल बोलोगे. फ्रॉम दिस आंसर यू आर गोइंग टू गेट इन जूल. इससे आंसर किस में आएगा? जूल में आएगा बच्चों. इससे आंसर किस में आएगा? जूल पर मोल. ओके, बिकॉज वी आर यूजिंग मास 1 मोल. ओके, मास 1 मोल है तो मोल आप हटा भी दो, बिकॉज वी आर यूजिंग मास 1 मोल ओनली. सो द आंसर यू आर गोइंग टू गेट इन जूल. बाद में उसको किलो जूल में कन्वर्ट आपको करना पड़ेगा. सो द टेम्परेचर इज 0 डिग्री सेल्सियस मींस 273.15 ln v2. द फाइनल वॉल्यूम इज दिस. Final volume is this 44.8 divided by initial volume is 22.4, which is nothing but 2. तो इसको सोल्व करोगे बच्चों, you will get the isothermal work. You will get the isothermal work which will come out 1.574 kilojoule. 1.574 kilojoule. मैंने इसको डिवाइड कर दिया बच्चों. एक्चुअल में तो कितना आएगा? You will get 1574 joule, या इसको आप कर सकते हो 1.574 kilojoule. Dividing this 1574, dividing 1.74 by 1000, you will get answer in kilojoule. 74. ठीक है बच्चों? Yes. Yes, similarly for the second process also you can find out. सेकेंड प्रोसेस के लिए आप निकाल सकते हो the work for the constant pressure process. So for constant pressure process, guys, what is work? Work is nothing but PdV. So W2 is nothing but PdV. What is the pressure, guys? It is expanding against the final pressure. Expanding against a final pressure of the gas. Expanding against a final pressure of the gas. Argon is expanded isothermally at 0 degrees Celsius from 22.4 decimeter cube, this much of the volume. Final pressure of the gas. So final pressure कहां से निकालोगे बच्चों? From where you are going to get the final pressure? You know the ideal gas equation? PV equal to mRT. Okay, या इसको आप लिख सकते हो PV equal to N R bar T. So from this you can write final pressure is nothing but final moles are same, 1 mole. Universal gas constant is 8.314. The final temperature क्या हो जाएगा आपका? This is final temperature T final divided by final volume. Final volume is 44.8 decimeter cube. So it will be 10 की power minus 3. 10 की power minus 3 meter cube. Okay. 10 की power minus 3 meter cube. P final is nothing but 1 into 8.314 into T final divided by this. Okay. But as there is no such mention about the T final, but one thing is common. इस पूरे डेटा के लिए one thing is common. The temperature is constant. So temperature is constant. So the T initial equal to T final. In first case, you are isothermally expanding at constant temperature. Second case, it is expanding against a constant external pressure, which is nothing but equal to the final pressure of the gas, T final. And in third case, it is expanding freely. Because in all the three cases, the temperature is constant. Initial temperature, final temperature, both are constant. Because you know, initial temperature, final temperature, that is same in free expansion also. In this case also, is saying the temperature is same, but the gas is expanding against a final pressure, against a pressure, external pressure, which is equal to the final pressure of the gas. So this also you can put it 273.15. Solving this, you will get the final pressure. आप इसको सोल्व करोगे बच्चों, फाइनल प्रेशर आपका पास आ जाएगा, which will come out 50.691 kilopascal. 50.691 kilopascal. Only you need to remember one thing. Final volume you need to use. If you use the initial volume, then you will get the initial pressure. If you use the final volume, then only you are going to get the final pressure. Temperature is remaining. Temperature is going to remain same. Okay. तो इसको अगर आप यहाँ पे put करोगे बच्चों, if you put it here, the final pressure, which is nothing but 50.691, which we calculated, which is dV. dV is nothing but this minus this. दोनों का difference करोगे, it will come out 22.4 only, multiply by 10 की power minus 3. ठीक है? So answer will come out 1.135 kilojoule. 1.135 kilojoule. So in first case, we got the answer 1.75. Second case, we are getting answer 1.13. And the free expansion work is 0. So option A क्या हो जाएगा? Answer हो जाएगा. Okay. But I don't know why actually they have mentioned here negative sign, because they are saying the gas is expanding. So if gas is expanding, means boundaries of a closed system, if they are expanding, you're going to get the positive work. So work will be positive. This also positive, this also positive, this will be 0. Okay. But I don't know why actually in the options only, because I checked their assignments also, but I have not made any kind of changes in that, because it is not right. So in those their assignments only, their assignments also they mentioned minus, which is not right. In expansion, you are going to get the positive work. Volumes of a closed system, when the boundaries of a closed system are expanding, you are going to get the positive work. This is initial volume, this is final volume. अब या तो वो यहाँ पे डेटा कुछ गड़बड़ कर देता, यहाँ पे expansion ना बोल के बोलता compression है, then this will be right, then minus will be right. But in the expansion, you are going to get the positive work. ठीक है बच्चों? So option A is the right answer for this question. Let us now move to next question, question number 30. There is a room with 60 meter cube volume maintained at 300 Kelvin, 100 kilopascal, completely occupied by the air, which involves 21% oxygen by volume. It can be viewed as a mixture of ideal gases. Then what is the specific volume of the oxygen available within the room? आपसे पूछ रहा है specific volume of the oxygen available in the room. बहुत simple question है बच्चों. What is the specific volume of the oxygen available in the room? Can you solve this, guys? What is the specific volume of the oxygen available in the room? He is asking you the specific volume of the oxygen available in the room in meter cube per kg. Specific volume क्या होता है बच्चों? Specific volume is nothing but total volume divided by mass. Means specific volume of oxygen is nothing but total volume divided by mass of oxygen. So you need to first obtain the mass of the oxygen. आपको mass of oxygen निकालना है. Okay, and then if you will divide it, the total volume, if you will divide it by the mass of the oxygen, you will get the specific volume of the oxygen. थोड़ा सा घुमा के पूछा है, but question is very easy. If you know about Amigat's law, 1.875 is not right. No. Manogma, you need to check it again. 1.875 meter cube per kg is not right. देखो, he has given you the mole fraction. You know mole fraction क्या होता है? Partial volume of a gas to the total volume, partial pressure of a gas to the total pressure, number of moles of a gas to the total moles. उसे हम क्या बोलते हैं? Mole fraction. The volume of a gas to the total volume, pressure of a partial pressure of a gas to the total pressure, number of moles of a gas to the total number of moles, those are known as mole fraction. तो ये उसने आपको दिया है. This is nothing but 0.21. The mole fraction of the oxygen is 0.21. You know mole fraction, Amigat's law. Mole fraction क्या होता है? It is volume fraction also. It is pressure, partial pressure fraction also. Okay. So P1 by PT, V1 by VT is equal to N1 by NT. ठीक है? So अगर आपको वॉल्यूम फ्रैक्शन दिया है ना, वॉल्यूम फ्रैक्शन इज नथिंग बट मोल फ्रैक्शन. ओके, बट दैट इज नॉट मास फ्रैक्शन. वो मास फ्रैक्शन नहीं होता. मास फ्रैक्शन के लिए आपको अलग से पापड़ बेलने पड़ेंगे. बिकॉज इफ यू वांट टू फाइंड आउट इक्विवेलेंट कैरेक्टरिस्टिक गैस कांस्टेंट, इफ यू वांट टू फाइंड आउट इक्विवेलेंट स्पेसिफिक हीट, देन यू रिक्वायर व्हाट? यू रिक्वायर मास फ्रैक्शन. ठीक है? मोल फ्रैक्शन यू कैन यूज if you want to find out equivalent, if you want to find out equivalent molar specific heat. Equivalent molar specific heat will be you can find out using mole fraction. Equivalent molar basis पे क्या निकाल सकते हो? Equivalent specific heat CP, CP molar, CV molar, those you can find out using mole fraction. Okay, but mass fraction is required if you want to find out CP based on the mass basis, kilojoule per kg. I will tell you, don't worry. अभी देखो यहां से आप क्या निकाल सकते हो? यू कैन फाइंड आउट द पार्शियल वॉल्यूम ऑफ द गैस. दिस इज नथिंग बट पार्शियल वॉल्यूम ऑफ ऑक्सीजन. पार्शियल वॉल्यूम ऑफ ऑक्सीजन. This is partial volume of oxygen, which is equal to 0.21 into 60. This is partial volume of the oxygen. If you will take oxygen, you heard about this is Amigat's law, guys. इसे हम क्या बोलते हैं? Amigat's law. Amigat's law, which tells us the total volume. Like there is a partial Dalton's law of partial pressure also. There is Amigat's law also. Total volume of a gas is equal to the partial volume of the gases. If you will take, if you are having a ideal mixture of homogeneous gases, अगर आपके पास एक ideal mixtures है, okay, ideal mixtures of gases you are having, so the total volume of a gas will be equal to the partial volume of those gases taking individually at same pressure and temperature. Dalton's law of partial pressure tells us the total pressure of a gas is equal to the partial pressure of the gases taking them at what? Taking them at the same volume and same temperature. The pressure of that gas will be what? Partial pressure. Like suppose guys, in this room you are having mixture of gases. You are having nitrogen also, you are having oxygen also. Although they all are occupying the volume which is equal to the volume of the room. But if you will take individually oxygen, if you will take individually nitrogen, the volume occupied by the oxygen individually to maintain the same atmospheric pressure 101.325 kilopascal for the same temperature, room temperature, suppose say 27 degrees Celsius, the volume occupied by the oxygen, that is partial volume of the oxygen. Okay, partial pressure क्या होता है बच्चों? Partial pressure of the gas is the pressure of the gas occupied if you will take the gas individually at the same volume at the same temperature. Same volume, same temperature पे लोगे, the pressure which you are going to get, that is a partial pressure. If you will take the gas at the same pressure, same temperature, the volume occupied by the gas is the partial volume. So these two things you need to know, partial volume and partial pressure. Partial pressure को relate करता है Dalton's law of partial pressure, partial volume को relate करता है आपका Amigat's law of partial volume. ठीक है, तो यहां से आपके पास partial volume आ जाएगा. So partial volume will be 0.21 into 60 into the pressure of the gas is nothing but pressure कितना है? Pressure is 100 kilopascal. So the pressure is 100 kilopascal equal to the mass of oxygen into characteristic gas constant of the oxygen, which is 8.314 divided by 32 into temperature of the oxygen. Temperature कितना है बच्चों? Temperature is 300 Kelvin. Okay, temperature is 300 Kelvin. So solving this, you will get mass of oxygen. इसको solve करोगे तो आपके पास क्या आ जाएगा? You will get the mass of the oxygen. Okay, you will get mass of the oxygen, and then you need to simply divide the volume divided by mass of oxygen. Volume कितना है? Actual में gas is occupying entire volume 60 meter cube. So 60 divided by mass of oxygen, you will get the specific volume. So first tell me guys, what mass of oxygen you are getting? Solving this guys, mass of oxygen बताओ. What mass of oxygen you are getting? और mass of oxygen को अगर आप यहां पुट करोगे, the specific volume which you are going to get, it will be equal to 3.71 meter cube per kg. 3.71 meter cube per kg. Please check and tell me guys, how many of you are getting this answer? Guys, there is a difference. There is a difference between Amagat's law and Dalton's law of partial pressure. देखो, if you are getting the answer in this range guys, 3.6 to 3.8, your answer is right. देखो मैं थोड़ा सा बता देता हूं आपको, Dalton's law में क्या कहता है? Like ये मिक्सचर आपके पास, this is a mixture of gases. ये कोई मिक्सचर है at a pressure P, temperature T, volume V. Okay. This is a mixture of gas, 3 gases. मान लीजिए 3 gases का मिक्सचर है, तो इन gases को what you need to do? आपको क्या करना है? आपको अलग अलग तरह पे लेना है at the same volume. Volume is same. This is volume V. This is temperature T. So the pressure will be P1. Same volume, same temperature. Pressure will be P2. Same volume, temperature T. Pressure will be P3. Suppose this is a mixture, guys. This is the mixture of 3 gases. ये mixture है 3 gases का. इसके अंदर 3 तरह की gases है. 1, 2, 3. These are the 3 gases. Okay. This is a chamber. This is a room in which there are 3 gases. Okay. There are 3 gases. 1, 2, 3. So if you will take those 3 gases individually, at same volume, at same temperature, so volume, temperature are same, so the pressure of that gas will be P1, partial pressure of the gas. Like जो अगर इस room में जो oxygen है बच्चों, उस oxygen को, like suppose the volume of this room is 60 meter cube. So individually if you will take oxygen, 60 meter cube oxygen, if you will take in a room, only oxygen, at the same temperature, 27 degrees Celsius, the pressure of that oxygen is what? That will be the partial pressure of the oxygen, which is P1. Similarly, if you will take the nitrogen individually at the same volume, same temperature, the pressure occupied by the gas will be P2, and obviously it will be less than the total pressure, because the total pressure P will be equal to P1 plus P2 plus P3. Yes or no? This is the Dalton's law. ये तो क्या कहता है अपने को? Dalton's law. Amagat's law क्या कहता है बच्चों? Amagat's law कहता है, if you are having a mixture of gases, like such that you are having a mixture of gases, this is a pressure P, temperature T, volume V. Okay, this is a mixture of 3 gases. Okay, this is a mixture of 3 gases. This is also a mixture of 3 gases. Now you need to take these 3 gases individually. इनको भी क्या करना, आपको individually लेना है. But what is the condition? You need to take them individually. At same pressure. Now you want to keep the pressure same, so volume will decrease. You want pressure same, so this is at a pressure P, temperature T. So if you want to keep pressure, temperature same, the volume will reduce, so volume will be V1. And again, gas 2, if you will take at the same pressure, same temperature, the volume occupied gas by that gas also, that is going to reduce as compared to the total volume V2. And similarly, the gas 3, if you will take at the same pressure, same temperature, the volume of that gas will be V3. So Amagat's law, if you will take individually, if you are having a homogeneous mixture of various gases, so if you will take a gas, those gases individually at same pressure, same temperature, the volume occupied by those gases is known as partial volumes, and the total volume of a mixture of gases will be equal to the partial volume of a gas. Means the total volume V is equal to the partial volume V1, partial volume V2, partial volume 3. This is known as what? This is known as Amagat's law, and this is known as Dalton's law of partial pressure. Okay, and what is the relationship, guys? In both the cases, the P1 by P total, the V1 by V total, this is equal to N1 by N total. This is nothing but mole friction. इसे हम क्या बोलते हैं? मोल फ्रिक्शन. इसको बोलते हैं वॉल्यूम फ्रिक्शन. This is pressure friction, this is mole friction. All three are equal to mole friction only. तो आप इसको mole friction भी बोल सकते हो. Number of moles of a gas as compared to the total number of moles. ठीक है बच्चों? Is that clear? ठीक है, चलिए. So first we applied that analysis. We calculated the mass of the oxygen based on its partial volume. Then we divided by the total volume by the mass of the gas. We got the answer for the specific volume of the gas. चलिए, let's move to next question. Again similar type of question. Now you need to apply your mind. अगर आपने इससे पहले वाला क्वेश्चन समझा है, then this question will be very easy for you. Okay guys, अगर पहले वाला क्वेश्चन आपने समझ लिया है, then this will be very easy for you. If air is assumed to be a mixture of two ideal gases, air is assumed as a mixture of two ideal gases, namely nitrogen and oxygen, with this volume ratio is this. So this is the volume ratio. So can I say the mole fraction of nitrogen is nothing but 4 by 5. The mole fraction means it is V1 by V total. Okay, yeah, it is P1 by P total. Yes or no? Or it is N1 by N total. तो मैं नाइट्रोजन के लिए यूज कर रहा हूं 1. नाइट्रोजन इज 1 फॉर मी एंड ऑक्सीजन इज 2 फॉर मी. नाइट्रोजन के लिए मैं 1 यूज कर रहा हूं, ऑक्सीजन के लिए आई एम यूजिंग 2. Okay, similarly he's saying the volume ratio is this, means the mole fraction for the oxygen is nothing but 1 by 5. So it will be 1 by 5. अब कहोगे सर ये कैसे आया? This you can write it something like this, guys. So volume fraction, volume of the nitrogen divided by volume of the oxygen is equal to 4:1. So the volume fraction of the oxygen divided by total volume is nothing but, ये क्या हो जाएगा? It will be what? 4 times, ये क्या है? वॉल्यूम ऑफ द नाइट्रोजन. हाँ, नाइट्रोजन एंड ऑक्सीजन इज 4 by 5. ठीक है, तो फॉर ऑक्सीजन, व्हाट इज द वॉल्यूम ऑफ द ऑक्सीजन, गाइस? वॉल्यूम ऑफ द ऑक्सीजन विल बी वॉल्यूम ऑफ नाइट्रोजन डिवाइड बाय 4. Okay, what is the total volume, guys? Total volume will be volume of nitrogen plus volume of oxygen. तो यहां से भी आप एनालिसिस करोगे, then also you are going to get 1 by 4. So it's up to you. You want to calculate it something like this, or based on the data directly you can write the mole fraction for the nitrogen, the mole fraction for the oxygen is 1 by 5. I think ये ratio से भी आप easily लिख सकते हो. So ratio total volume is 5, the volume of the nitrogen is 4, so 4 by 5 is the volume fraction for the nitrogen. Volume ratio for oxygen is 1, so 1 by 5 this is the mole fraction for the oxygen. Okay, तो इसको आप लिख सकते हो V2 by V total, P2 by P total, या इसको लिख सकते हो आप N2 by N total. Let's see what is asking you. What is the apparent molecular weight? आपसे पूछ रहा है apparent molecular weight. Now, guys, he is asking you apparent molecular weight in kg per kilomole, because apparent molecular weight in kg per kilomole only. So here, for finding out molecular weight, the mole fraction is going to help you. The apparent or equivalent molecular weight. The apparent or equivalent molecular weight is nothing but N1 M1 plus N2 M2 divided by N1 plus M2. This is the formula, guys. N1 M1 plus N2 M2 divided by N1 plus M2. या इसको आप ऐसा लिख सकते हो, equivalent molecular weight of a mixture of gas is nothing but X1 by M1 into M1 plus X2 into M2, where X1 is the mole fraction of gas 1, X2 is the mole fraction of gas 2. So directly you can use mole fraction, or you can use N1 M1 plus N2 M2 divided by N1 plus N2. So N1 by N1 plus M2 is nothing but mole fraction X1. In some books you will get expression Y also. Okay, ठीक है. Okay, I will try to share. मैं इसको share करता हूं अभी. Comment in the comment section only you are going to find the link, guys. Just wait for 1 minute. गुरुविंदर सर, सर बच्चे वो डाउनलोड नहीं कर पा रहे, प्लीज उसको शेयर कर दो आप. हाँ, काफी बच्चे बोल रहे हैं. Just wait for 1 minute, guys. Ayush, in next 1 minute you will get the link to download this workbook assignment. ठीक है बच्चों, just wait for 1 minute. So M equivalent is this. So now if you want to find out equivalent molecular weight, so equivalent molecular weight is equal to X1. What is X1 for nitrogen? It is 4 by 5. What is the molecular weight for nitrogen? It is 28, plus the mole fraction for oxygen is 1 by 5. molecular weight of oxygen is 32. Solve करोगे, you will get the equivalent molecular weight. Can you tell me the answer, guys? What is the equivalent molecular weight? तो बच्चों ये याद रखो, देखो मैं यहां लिख देता हूं, इन मोलिकुलर वेट, इक्विवेलेंट मोलिकुलर वेट, तो यहां पे तो आपके पास मोल फ्रैक्शन काम आएगा, N1 M1 plus N2 M2 plus N3 M3, something like this, divide by N1 plus M2 plus N3, something like this. तो ये तो एम इक्विवेलेंट में काम आएगा. सीपी में कौन काम आएगा? अगर आपको निकालना है सीपी मोलर इक्विवेलेंट या सीवी मोलर, दिस इज सीपी मोलर, यहां पे भी देन अगेन यू कैन यूज N1 CpM1 plus N2 CpM2, something like this, divide by N1 plus M2. This is Cp molar, N1 plus N2 plus so on. But if you want Cp in kilojoule per kg, in kilojoule per kg, so then you cannot use mole fraction. तब आपको क्या यूज करना पड़ेगा? Then you need to use mass fraction. M1 Cp1, M2 Cp2, M3 Cp3, and then so on, divide by M1 plus M2 plus M3, something like this. So this is known as mass fraction. This is mass fraction. M1 by M total, mass fraction. N1 by N total, this is mole fraction. So you need to see what they are asking. If they are asking you the molar specific heat, then you can use mole fraction. Molar specific heat, molar Cp, molar Cv, a molecular weight, if they are asking you, then you need to use the mole fraction. But if they are asking you Cp value in kilojoule per kg, if they are asking you R equivalent, R is also in kilojoule per kg, so then also you need to use here M1 R1 plus M2 R2 plus M3 R3, and then you need to divide it by M1 plus M2 plus M3. Got the idea, guys? So this is nothing but this is known as mass fraction. इसे हम क्या बोलेंगे? Mass fraction, XM, mass fraction, M1 by M total. This is mass friction. इसे हम क्या बोलते हैं बच्चों? Mass friction. Got the idea, guys? ठीक है, समझ में आया? What is the difference between mass friction and mole friction? So what we did, guys, we divided, na? We calculated the guys, when you are having a air inside a room, what volume it is occupying? So when we are calculating the partial volume when we are calculating, so hypothetically we are thinking we are putting the air at same pressure, same temperature, we are taking the air individually, we are taking the oxygen individually, taking at same temperature, same pressure, so its volume will be V1. What the idea? But in actual case, the air is going to occupy volume of the room only. If you are having mixture of nitrogen, oxygen, all gases, they all are occupying the volume. And what is that volume? The volume is the volume of the room. So that's why the volume of the room divided by mass of the oxygen. But for finding out the mass of oxygen, guys, you can ask me, sir, why you have used here V1? Why not total volume? Why not total volume? Guys, if you will use it here, the total pressure, the total volume, then here you will have mass total also, the R equivalent also, and the total temperature. You can use this equation to find out total mass. This equation you can use for finding out the total mass. But if you want to find out the mass of any one gas, so mass of any one gas will be what? The pressure. Because when you are using the Ma gets low, अब देखो दो रास्ते हैं आपके पास. You can use the Dalton's law of partial pressure. So you can write it here, P1 into V total. Okay, P1 into V total, this is V total equal to M1 R1 T1. This is one way you can use this. या तो आप ये use कर लो, या you can use this. What? You can use this total pressure, partial volume V1, M1 R T1, or use this. T1 is same. So T1 T2 is not different. यहाँ पे आप T1 हटा ही दो, because T1 T all are same. Okay. Got the point, guys? So because we want M1, अपने को mass of oxygen चाहिए था. We are interested in mass of oxygen only. So you need to use the partial volume of the oxygen. If you will use the total volume, you will use the total pressure, then you are going to get the total mass. You will not get the mass of the oxygen. But we want mass of oxygen only, because we are interested in specific volume of the oxygen. I think it is clear, guys. But ध्यान क्या रखना है आपको? Total pressure, total volume. ठीक है? हाँ, बट वहां पे आपको टोटल प्रेशर, आपको व्हाट आई टोल्ड यू गाइस, दिस इज सेम, like when you are putting this, This is same, like x equal to 0.21 equal to p1 by p total. Then also you will get the same answer. What I told you guys, this is equal to v1 by v2 also, this is equal to v1 by v total also. The volume fraction, pressure fraction, both are same, so you can use anyone. दोनों से आपका आंसर एक ही आएगा बच्चों. Like suppose if you will use here p1, so p1 is nothing but here, if you want to use p1, if you want to use volume 60 only, sir, we are confused with that partial volume, we want to use partial pressure, so there is no problem, you can use partial pressure also. But partial pressure क्या होगा, it will be 0.21 into total pressure which is 100, okay, into the total volume which is 60, equal to mass of oxygen into 8.314 divided by 60 into the temperature. Temperature is same in both the cases, 300 Kelvin. Okay, so what is the difference, whether you are multiplying this 0.21 with 100 or whether you are multiplying this 0.21 with 60, what is the difference? There is no difference. Okay, so it's up to you. But you need to be very clear, you need to clear about the Amagat's law, you need to clear about the partial law, Dalton's law of partial pressure, and you need to know the relationship because both are same. So you can use it here, 0.2 multiply by 60 or 0.21 multiply by 100, it's up to you guys. ओके, बट दोनों को मत कर देना, ऐसा मत करना कि प्रेशर भी लिख दो P1 एंड वॉल्यूम आल्सो V1, दैट विल बी रॉन्ग. ओके, दैट विल बी रॉन्ग. देयर आर टू केसेस, Dalton's law, taking the gas at same volume, same temperature, the pressure will be partial pressure. Taking the gas at same pressure, same temperature, the volume will be V1. So it's up to you. You can use V1 concept or P1 concept. In both the cases, the answer will be same. ठीक है बच्चों, is that clear? ये समझ में आया? ये समझ में आया? Is that clear? चलिए, लेट अस नाउ मूव टू नेक्स्ट प्रॉब्लम. मेरे ख्याल से ये आपने आंसर कर ही दिया बच्चों. यस, ये आपका आंसर आ गया. व्हाट इज द इक्विवेलेंट मॉलिक्यूलर वेट? व्हाट इज द इक्विवेलेंट मॉलिक्यूलर वेट गाइस? क्या आ रहा है इक्विवेलेंट मॉलिक्यूलर वेट? आपने अभी तक आंसर नहीं किया. नोबडी आंसर्ड गाइस इक्विवेलेंट मॉलिक्यूलर वेट. प्लीज टेल मी द इक्विवेलेंट मॉलिक्यूलर वेट गाइस. तो ये सारा डेटा जो मैंने यहां पुट किया है, इसको अगर आप सोल्व करोगे, इफ यू विल सोल्व दिस, you will get the equivalent molecular weight, and if you are getting this answer in this range 28.6 to 29, 28.6 to 29, your answer is right. बिल्कुल मनोगमा, बिल्कुल सही. गौरव, your answer is also right. 28.6 to 29, your answers are right. Let's move to next question now. Guys, there is a 100 meter cube storage tank with fuel gases at 20 degrees Celsius, 100 kilopascal, containing a mixture of C2H2, C3H3. So there are three gases: C2H2, C3H8, C4H10. इसको मैं लिख देता हूं 1, ये मेरे लिए 1 है. इसको मैं लिख देता हूं 2 और इसको मैं लिख देता हूं 3. ये तीन गैसेस हैं. मिक्सचर आपके पास in a particular room which is having volume the total volume is 100 meter cube. In a room, you are having a mixture of these three fuel gases, because these all are combustible gases, hydrocarbons हैं, so they are combustible gases. For these you are having a mixture. The test show a partial pressure of this. इसका partial pressure कितना है बच्चों? इसका P1 partial pressure is 15 kilopascal. For this the partial pressure P2 is 65 kilopascal. For this the partial pressure P3 is कितना? इसका नहीं दिया है ना. For this the partial pressure is not given. इसका partial pressure अपने को नहीं पता, but that also we can write it very easily. अब अपने को पता ना कि P1 plus P2 plus P3 equal to P total. So this is 15, this is 65. 65 plus 15, it will be 80. So definitely it will be 120 kilopascal. From where we are writing? The total pressure is 100 kilopascal. The total pressure is 100 kilopascal. So for this the partial pressure is 15. For this the partial pressure is 65. For this the partial pressure will be total pressure minus P1 minus P2. You know, total pressure equal to P1 plus P2 plus P3. The total pressure is 100. This is given to you 15. This is given to you 65. So P3 will be 20 kilopascal based on that. If all three components can be considered as ideal gases, then what is the mass of the C4H4 in the mixture? आपसे mass पूछ रहा है बच्चों. Now he's asking you the mass. So from this, you are going to get how to convert mole fraction into mass fraction. Okay, how to convert mole fraction into mass fraction. So आपसे mass पूछ रहा है, because if you are able to calculate mass of this, you will be in the same process. You will get the mass of this also, mass of this also, and if you are able to get mass of all, then you will easily get the mass fraction. And if you are able to get the mass fraction, then easily you can calculate equivalent R, equivalent CP, CV. अच्छा, you are telling me the answer. Manogma is saying answer. चलो मैं आंसर चेक कर लेता हूं. M3 is no. You need to check calculation. Manogma, 9.54 is not right. You need to check your calculation. 9.54 is not right. ठीक है? Please check it again. This is not right. So you want to find out mass of what? C4H10. तो कैसे निकालोगे बच्चों? How you will find out the mass? ठीक है? How you will find out the mass? Is there any kind of hint is required, guys? कोई hint चाहिए? कोई hint चाहिए? The hint is this. कौन सा hint? This concept which I discussed. If you want to find out the mass of oxygen, use mole fraction. Mole fraction means volume fraction. Volume fraction is nothing but equal to mole fraction. So you are having, from this analysis, you are having the partial pressure. So easily you can calculate mole fraction, guys. यहाँ से आप क्या calculate कर सकते हो? You can easily calculate x1. X1 will be P1 by P total. X2 will be P2 by P total. X3 will be P3 by P total. और ये लिखने की भी जरूरत नहीं है बच्चों, because the total pressure is 100. So this is nothing but 0.15. This is nothing but 0.65, and this is nothing but 0.2. So you are having the mole fraction. Okay, you are having the mole fraction, and I told you the mole fraction is nothing but volume fraction. So for C4H4, for which we want mass for C4H10 means 3. इसके लिए अपने को mass चाहिए, we want M3. अपने को निकालना है M3. Okay, so guys, there are two ways. क्या कर सकते हो आप? You can write it here, P1 V equal to M, sorry 3 लिखता हूं मैं, it is better to write 3. So P3 V equal to M3 R3T. This is one equation you can use. ये यूज कर लो, या दूसरा क्या यूज कर सकते हो? You can use P V3 equal to M3 R3T. You can use this. Means you can use partial pressure concept. You can use partial pressure concept, or you can use partial volume concept. It's totally up to you. Gaurav, your answer is right. गौरव का आंसर बिल्कुल सही है. गौरव ने सबसे पहले राइट आंसर दिया है. 47.6 is the right answer. Those of you who are getting the answer in the range of 47.1 to 48.3, that is a range for this question. So you can use this or you can use this. It's totally up to you. Okay. So P3 कितना है बच्चों? अब ये यूज कर लो, पार्शियल प्रेशर वाला यूज कर लो. So P3 is nothing but 0.2 of the P total, means this is 20 kilopascal. So this is 20. The volume is 100 equal to M3. The R will be 8.314 by the M3 into T. Temperature कितना है बच्चों? Temperature for all is 20 degrees Celsius. Okay. Temperature is 20 degrees Celsius means 293.15. 293.15. From this equation you will get M3. But M3 कहां से आएगा? This is mass, this is molecular weight. Mass and molecular weight. So can I write it here? The molecular weight M3 C4. What is the molecular weight for carbon? 12. So 12 into 4 you will have 48. 48 plus 10 you will have 58. So molecular weight will be 58, guys. ये analysis आपको करना पड़ेगा. M3 will be 58. मैं इसका भी बता देता हूं so that you will be check, although it is not required. M2 will be 12 36, 36 और 8, it will be 44. Okay. Similarly, you can check it here. M1 also. आप M1 भी check कर लो. M1 will be 24 and this will be 26. 26 kg per kilomole या gram per mole. Kg per kilomole or gram per mole. Okay. चलिए. So now you are having all those things. सब चीजें अपने पास है. 20 into 100 equal to M3 into 8.314 divided by 58 into 293.15. So now can you tell me, guys, what mass M3 you are getting? Yes. Simple question, guys, but these type of questions are very much important. And you know, last scenarios, last previous year questions, if you will check from GATE, XE, mechanical, they are asking these times. They are asking these type of questions, है ना? So you need to practice. Pure substances में mixtures का कैसे properties निकालनी है, that you need to check. ठीक है बच्चों? Is that clear? सही है. So now tell me what answer you are getting for this question. 47.59. Very good, guys. अभी बहुत सारे बच्चे आंसर कर रहे हैं. And yes, if you are getting answer in this range, this is the right answer for this question. Accepted answer range is 47.1 to 48.3. 47.1 to 48.3 is the right range for this question. Sushil, your answer is right. Manogma, your answer is also very right. चलिए, let us now move to next question. अभी आप मेरे से पूछ सकते हो, सर can we use this also? क्या हम ये भी use कर सकते हैं? You can use this also, partial volume also. Okay, because both are same. From this also, the answer you are going to get same. चलिए, next question है, there is a rigid insulated tank containing 12 kg of oxygen at 200 kilopascal to 220 Kelvin, which is kept separated by membrane. तो कुछ इस तरह का arrangement है. There is a rigid insulated tank. Okay, there is a rigid insulated tank. So this tank is insulated. This is a rigid insulated tank, means volume constant, and tank is insulated. Okay, the tank is insulated. First part contains 12 kg oxygen, 12 kg oxygen, 200 kilopascal, 280 Kelvin. Second part contains 26 kg carbon dioxide, 400 kilopascal, 360 Kelvin. This membrane is removed. ये तो क्या है? Membrane है. This is membrane. Okay, if you will remove this membrane, if you will carry out the rupture of this membrane, allowing the gases to mix, and if you will allow these gases to mix, they are asking you the final state. What is the final temperature? What is the final pressure? Final temperature, final pressure. Then the final temperature. अच्छा, आपसे सिर्फ final temperature ही पूछा है. So he is only asking you final temperature. So how to find out the final temperature, guys? Can you find out final temperature? बहुत simple question है बच्चों. Very simple question. You need to apply your mind. Energy balance equation. Yes, तो वो आपको निकालना पड़ेगा. I already told you how to find out the equivalent, characteristic gas constant. Equivalent, yes. Energy balance you need to apply. Yes, very good. You need to go with energy balance. What is energy balance? Sir, M1, suppose this is 1, this is 2. This is 1, this is 2. So M1H1 plus M2H2 equal to M3H3. Yes or no? So M1 is what? M1 is 12 kg, M2 is 26 kg, M3 is 38 kg. Yes or no? Yes sir, this is right. बिल्कुल सही है. H1 को क्या लिख सकता हूं मैं? H1 को लिख सकता हूं मैं CP1 T1, H2 को लिख सकता हूं मैं CP2 T2 और H3 को लिख सकता हूं मैं CP3 या CP equivalent T3. CP equivalent T3. तो T3 तो अननोन है, इसको मैं लिख देता हूं. इसको मैं क्या लिखता हूं? CP3 ना लिख के, चलो मैं दोनों तरह से लिख देता हूं. यू कैन राइट इट एज CP3 T3, CP3 T3, और you can write it as CP equivalent into T final. In any way you can write. Okay, so the final formula will be T final equal to M1 CP1 T1 plus M2 CP2 T2 divided by M1 plus M2 into CP equivalent. CP equivalent. तो CP equivalent बता देता हूं कहां से आएगा. CP equivalent will be M1 CP1 M2 CP2 divided by M1 plus M2. More mass fraction. Mass fraction you will use. So guys, if I will give you CP1 and CP2, अगर मैं आपको ऑक्सीजन के लिए and for carbon dioxide, if I will give you CP1 and CP2, you will easily get the answer. So that data I am giving you, because in these NPTEL assignment they presume and they generally don't give those kind of data because they assume the student is going to refer some kind of standard textbook, and from that he is going to get those properties. But here in GATE you are going to get those. So here I'm going to give you Cp for the oxygen. I'm giving you 0.918 kilojoule per kg Kelvin. This is Cp for the oxygen. Similarly, Cp for the carbon dioxide, Cp for CO2, I'm giving you 0.848 kilojoule per kg Kelvin. So these two values I am giving you guys, Cp oxygen and Cp for the carbon dioxide, because you are not going to get these directly. Directly to nahi aayegi. For R you can find out based on universal gas constant divided by the molecular weight, but R Cp you will not get. Sorry. ठीक है बच्चों. So I'm giving you these two values. Okay, Cp for the oxygen, Cp for the carbon dioxide. Okay, based on that means Cp1 इसको आप Cp1 भी लिख सकते हो बच्चों. This is Cp1. ऑक्सीजन को मैंने Cp1, this is Cp1 and this is Cp2. कार्बन डाइऑक्साइड को मैंने 2 लिया है, ऑक्सीजन को मैंने 1 लिया है. ओके, सो Cp1 Cp2 you know, T1 T2 all those things also given to you. ओके, सब पता है आपको, टेम्परेचर भी पता है. सो Cp equivalent you will get, mass 1, final temperature easily you will get. So can you tell me guys answer for this question? What is the final temperature you are getting? So with only energy balance you are going to get the answer for this question. With only energy balance you are going to get the answer. But what is the difficulty? You need to check, you need to find out the equivalent specific heat. Okay, based on the data. So it's actually a two-step question. First, you need to find out the equivalent specific heat. You need to use the energy balance equation. You need to, because you know those gases, they are superheated gases, oxygen, carbon dioxide. So easily you can write their enthalpies at CpT1. Ideal gas equation you can apply. For ideal gas, the enthalpy you can write it as CpT. Okay, and for H1 equal to CpT1, similarly H2 equal to CpT2, assuming those gases as an ideal gases. तो गेट में तो लिखेगा बच्चों, इन गेट ही इज गोइंग टू राइट ईच एंड एवरीथिंग इन वेरी क्रिस्टल क्लियर मैनर. You can assume those gases as an ideal gases. Okay, what is the final temperature if Cp of oxygen is this, Cp of carbon dioxide is this, something like this. बच्चों कहीं ना कहीं आप कैलकुलेशन मिस्टेक आप कर रहे हो इसमें, some kind of calculation mistake you are making. एक ही बच्चे का अभी तक आंसर आया, वो भी बहुत क्लोज है. गौरव ने कुछ क्लोज है, but it is not exactly, because when I calculated I got the answer 333.3, 333.3. I got that answer. तो आपका भी वही आना चाहिए, because they mentioned this range. उन्होंने ये रेंज मेंशन की है बच्चों, 330 to 340. I calculated initially and I got the answer final temperature 333.3 Kelvin. You also you need to check your calculation again. Why actually you are not getting this? तो आपका ये आंसर आना चाहिए बच्चों. Please check it again. If you are getting answer 333, Sushil, your answer is very right. Sushil का answer is exactly matching with me. Sushil 333.3 is the right answer. बिल्कुल सही, and it is in the range 330 to 340 Kelvin. So guys, don't, you know, I think you are approximating some of the things when you are using your calculator. I think you are missing some of the important data. तो कुछ भी अपने आप अप्रोक्सीमेट मत करो. करेक्ट टू 1 डेसिमल प्लेस, करेक्ट टू 1 डेसिमल प्लेस. ये तो आपको अगर करेक्ट करना भी है तो यू नीड टू यूज 1 डेसिमल प्लेस तक आपको उसको पुट करना पड़ेगा. नाउ लोट्स ऑफ स्टूडेंट दे आर आंसरिंग यस. सो प्लीज चेक एंड कंफर्म गाइस, इज दैट फाइन? लेट्स मूव टू नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन पे मूव करते हैं. अभी है हमारा क्वेश्चन नंबर 17. चलिए. ए मिक्सचर ऑफ 0.5 kg nitrogen, 0.5 kg oxygen is kept inside a piston cylinder arrangement at 100 kilopascal, 300 Kelvin. Now 800 kilojoule of heat is added at constant pressure. If both nitrogen and oxygen are assumed to be perfect gases with the Cp this and this, then the increase in entropy of the mixture. Very, very good question, guys. He's asking you the entropy change, the entropy of the mixture during this process, the entropy of the mixture after the heat addition process. The entropy of the mixture after the heat addition process. Okay guys, so you're having the gas mixture at pressure 100 kilopascal, temperature 300 kilo Kelvin, okay, kept inside a piston cylinder arrangement. both nitrogen and oxygen can be assumed as a perfect gases. CPCV value is asking you the increase in entropy of the mixture. आपसे क्या पूछ रहा है? Increase in entropy of the mixture. S2 minus S1 means change in entropy of the system. Change in entropy of the system. Yes guys, so please answer, try to solve this very good question. Entropy का question आ गया बच्चों. I think next 3-4 questions are related to entropy only. Entropy generation. Next 3-4 questions are related to that. Is there any hint required guys? Can you solve this question? क्या इसको solve करोगे? Guys, you know, mixture you are having although, but that mixture also you can consider it as an ideal gas. So S2 minus S1 for the ideal gas, you can write it as Cp ln T2 by T1 minus R ln P2 by P1. Cp ln T2 by T1 minus R ln P2 by P1. This is the entropy change for a ideal gas. But यहाँ पे लिखना क्या पड़ेगा आपको? Cp equivalent. This is Cp equivalent ln T final by T initial. T final by T initial. This is S2 minus S1. The specific entropy change, अगर आपको चाहिए किलो जूल पर केल्विन में, तो आपको मास से मल्टीप्लाई करना पड़ेगा. मास, where mass is what? 0.5 into 0.5, mass is 1 only. Mass is 1 only. तो इसको आप मल्टीप्लाई कर दो मास के साथ, mass of the mixture, and mass of the mixture is what? 0.5 plus 0.5, it is 1 kg only. The mass of the mixture is 0.5 into 0.5, 1 kg. 0.5 nitrogen, 0.5 oxygen, so the mass is 1 kg. Why actually I am removing this term? Because this term will be 0. This term will be 0. Why? Because when a heat transfer is there in a piston cylinder arrangement, here he has not mentioned that much very clearly, but in GATE he is going to mention it very clearly. This is a frictionless movement. In a piston cylinder arrangement, when you are supplying heat, the boundaries are free to expand. You are adding heat in a piston cylinder arrangement, and if there is no friction between the piston and the surface, if there is no friction, then that process you can approximate it as a constant pressure process. So heat addition in the mixture of a gases in a piston cylinder arrangement, it can be approximated as a constant pressure process. Are you getting? Okay, so indirectly this you need to assume, and this is given actually. Why? Because he has mentioned there is a piston cylinder arrangement, but one thing he needs to mention here, frictionless. Okay, frictionless. कई बार assignments में वो miss कर देते हैं, but in GATE they are going to mention it very clearly. Don't worry. Frictionless movement. So pressure is constant. If P2 equal to P1, then this term will be removed. So you will get the entropy change using this only, but you need to find out the final temperature. Final temperature कहाँ से आएगा बच्चों? From where you will get the final temperature? You know the heat transfer. You know the heat transfer. Okay. From heat transfer, can you get the can you get the this value? From heat transfer, can you get this value, guys? The final temperature easily you will get. Easily you will get. तो इसको आप heat transfer को at constant pressure heat transfer equal to what? Change in enthalpy. This is equal to change in enthalpy at pressure constant. Heat transfer at constant pressure, you know, constant heat transfer at constant volume is equal to change in internal energy. Heat transfer at constant volume equal to change in internal energy. Heat transfer at constant pressure is equal to change in enthalpy. Okay, so how much is the heat transfer? The heat transfer is 800 kilojoule, and it is equal to m Cp equivalent into dt T final minus T initial. M Cp equivalent T final minus T initial. Yes or no, guys? So how much is the heat addition? 800 kilojoule. So 800 you can equate it with mass. Mass is 1. Mixture mass is 1. What is Cp equivalent? That Cp equivalent you need to find out into T final minus T initial. The initial temperature is 300 Kelvin. Solving this, you will get the final temperature, and if you put final temperature here, you will get the answer. But before that, you need to calculate Cp equivalent also. आपको Cp equivalent भी निकालना पड़ेगा. And you know how you will get Cp equivalent, guys? Cp equivalent is equal to Cp1 m1 plus Cp2 m2 divided by m1 plus m2. Okay, so let me put it here. Cp equivalent, what is m1 guys? M1 is 0.5, so 0.5 into what is Cp1? Cp1 is a Cp for the nitrogen. Nitrogen के लिए कितना है? It is 0.922 plus. For oxygen also the mass is 0.5, so 0.5 into for oxygen it is given 1.042 divided by total mass. Total mass is 0.5 plus 0.5, it is 1 only. So 0.5 multiplied by 0.922 plus, मैं इसको थोड़ा साफ साफ लिख देता हूँ. Let me remove this, okay, so that you will get more clear. चलिए, so Cp equivalent is equal to Cp1, which is 0.922 multiplied by 0.5 plus Cp of the oxygen is 1.042 multiplied by 0.5 divided by m1 plus m2. So m1 plus m2 is 0.5 plus 0.5. Based on that you will get Cp equivalent. Cp equivalent आ जाएगा बच्चों, यहां से आ जाएगा आपके पास Cp equivalent because you are not having a single gas, you are having a mixture. So you will get Cp equivalent. Using that Cp equivalent here, you will get T final. T final आ जाएगा, and if you put T final here, you will get the entropy change. So now can you give me the answer, guys? Can you give me the answer for the entropy change? Yes. Manogma is saying 1.4509. Let me check, Manogma, your answer. बिल्कुल सही है. It is very right. So those are getting answer in the range of 1.2 to 1.4, guys. 1.2 to 1.4 kilojoule per Kelvin. So S2, this will be capital S because वो हमने mass से multiply कर दिया है. We multiplied with mass. So those are getting this in the range of 1.2 to 1.4 to 1.4 kilojoule per Kelvin. They are very right. So please check your answer, guys. If you are getting this answer in this range, 1.2, बिल्कुल Jagdish, your answer is also right. Jagdish, Manogma, your answers are very right. ठीक है बच्चों, तो क्वेश्चन बहुत अच्छा था. लेंदी लगेगा आपको, but the question is not that much difficult. क्वेश्चन बहुत अच्छा था because these type of questions are very very important, guys. क्वेश्चन बहुत easy है, only a 2 steps question. First you write the entropy change for the ideal gas. Pressure is constant, so this term will be removed. Okay, you will have this term. So from this you will get the idea. You need to calculate Cp equivalent because you cannot write Cp, because like for one gas it is very easy. For one gas you will write it here Cp ln T final by T initial. Okay, so Cp will be for that gas only, but here you are not having one gas, you are having a mixture. So that's why you need to find out first the Cp equivalent of that mixture. For that you can use this formula. So we are going step by step. Both step by step chal rahe hain. So already I have given you the idea how to calculate Cp equivalent. Okay, and if you know about that, easily you will put it here. You will get the final answer, T final, and then entropy change. चलिए let's move to next question. Question number 18. अभी कुछ question easy है, चलिए इसको answer करो बच्चों. Next question, 1 marks question in front of you. So this time initially we solved question related to entropy generation, and now you can relax for a second and you can try to answer this very simple question. Second law efficiency of a Shubham is saying T initial. Shubham, T initial is given. देखो, this is T initial. Shubham, the mixture is at temperature 300 Kelvin. Download the workbook. Shubham, workbook download करो. ठीक है, चलिए try to answer this question. Just wait a minute, guys. Yes. Yes. So please try to answer this simple question. second law efficiency for a refrigerator. Second law efficiency for a refrigerator. Option B. Some are saying option C is initially. Option B is the right answer, guys. B is the right answer. You know, guys, second law efficiency is nothing but this is known as relative efficiency. इसे हम क्या बोलते हैं? Relative efficiency. This is nothing but the for heat engine. It is what it is. First law efficiency, actual efficiency in comparison to the efficiency of Carnot or reversible cycle. So what is the efficiency of the engine in comparison to the efficiency of Carnot engine? That is known as second law efficiency. So this you can write it as W actual by W maximum. ये किसके लिए? This is for heat engine. This is for heat engine. Okay, this is for heat engine. But second law efficiency for a work absorbing device. Efficiency relative. This is relative, not reversible. ये reversible नहीं है. This is relative efficiency. Okay, relative efficiency. So this is nothing but COP actual by COP Carnot. COP actual by COP Carnot. Okay, so for refrigerator, it is nothing but how much reversible work you are giving divided by how much actual work you need to give. So this is the expression for the second law efficiency for work absorbing device. So for work producing device, this is the expression. Okay, top one is the expression for the second law efficiency for work producing device. Work producing. This is for work producing. Okay, and the lower one is for the work absorbing. This one, like this one, you need to use for the like compressor. Compressor के लिए भी यही लिखोगे आप, reversible work, actual work. Okay, like any kind of work absorbing device. Heat pump also. So this is for work absorbing device. Refrigerator, heat pump, work absorbing device. Okay, this you can write in terms of exergy also. Second law efficiency is nothing but the exergy utilized divided by exergy expanded. Exergy expanded. कितना आपने exergy expand किया, कितना आपने utilize किया. Okay, this is also you can write it as something like this, or you can write it as 1 minus exergy destruction divided by exergy expanded. Exergy destruction minus exergy expanded, or you can write it as 1 minus irreversibility divided by exergy expanded. Short में लिख रहा हूं बच्चों में. This is exergy expanded. Okay, I think this is now very clear. Exergy expanded, because the exergy destruction is nothing but irreversibility. How much exergy you have utilized? Exergy utilized is nothing but exergy expanded minus exergy destruction. कितना आपने यूटिलाइज किया, कितना आपने एक्सपैंड किया, कितना आपने डिस्ट्रॉय किया, डिवाइड बाय एक्सर्जी एक्सपेंडेड. ओके, एक्सर्जी एक्सपेंडेड मैं ऊपर भी सही कर देता हूं. दिस इज एक्सर्जी एक्सपेंडेड. सो अगर आप इसको थोड़ा सा सिंप्लीफाई करोगे, यू विल गेट 1 माइनस एक्सर्जी डिस्ट्रक्शन बाय एक्सर्जी एक्सपेंडेड. सो देयर आर मेनी वेज टू राइट द सेकंड लॉ एफिशिएंसी. In terms of exergy also you can write, in terms of relative efficiency also you can write. Okay, or in terms of available energy also you can write. इसको आप available energy की terms में भी लिख सकते हो, something like this: the A minimum divided by A, the minimum available energy. This is what minimum available energy. This is minimum available energy intake to perform a given task. Minimum available energy to perform a given task. A given task. कितना minimum available energy चाहिए to perform a given task, and what is the actual available energy you need to give? How much is the minimum available energy you need to give to perform a particular task? Minimum available energy given to perform a particular task. Okay, to perform a given task, A minimum divided by A actual. कितना actual में देना पड़ा? That ratio is what? This ratio is known as exergetic efficiency. Second law efficiency, there are many ways. You can name this as efficiency as second law efficiency, exergetic efficiency. This is nothing but what? How much actually you have utilized, how much exergy you have utilized, divide by how much exergy you have expended. What is the minimum available energy you need to give to perform a particular task, divide by what is the actual available energy you need to give for any kind of work absorbing device. Okay, for any kind of refrigerator heat pump, it is COP actual divided by COP ideal. For any kind of heat engine work producing device, it is efficiency actual divided by efficiency ideal, or it is W actual divided by W maximum, means W reversible. Okay, for kind of refrigerator, it is W reversible, how much reversible work you need to give, how much minimum available energy you need to give, how much, you know, how much minimum work, means reversible work you need to give, divided by how much actual work you are giving. Okay, so this B is the right answer. कितना minimum देना पड़ा, कितना minimum exergy आपको देना पड़ा to perform a particular task, divided by how much actual work you are giving. That ratio is known as exergetic efficiency. ठीक है बच्चों, चलिए let us move to next question. Availability of a system during a process. एक लाइन का क्वेश्चन है बच्चों, जल्दी से आंसर करना इसको. Availability of a system during a process. Availability पे क्या फर्क पड़ता है बच्चों? Availability of a system during a process. Availability क्या करती है? Availability क्या करती है? Remains constant. Energy always remains constant. In any process, energy remains constant, but availability is not a energy. It is a maximum work which you can get. Second law का statement क्या है? What is the statement of second law? There must be decrease in the available energy. So exergy destruction will be always there in a real process. In a real process, always there must be destroy of exergy. Work potential is going to lose. Work potential loss. Work potential loss. इसे हम क्या बोलते हैं? Irreversibility. Loss of available energy. This will be there. Exergy destruction will be always there in a real process. There must be decrease in the available energy always in a real process. So C is the right answer for this question. Question number 20, guys. In an industry, waste heat source having a amount of 300 kilowatt is available at 600 degrees Celsius. The ambient temperature is 25 degrees Celsius. The exergy of the waste heat. अभी कुछ क्वेश्चन एक्सर्जी से रिलेटेड है बच्चों. एक्सर्जी, एक्सर्जेटिक एफिशिएंसी, अवेलेबल एनर्जी. So please answer this question. He is asking you, in an industry there is a waste heat available. कितना waste heat available है बच्चों? कितना waste heat available है? Waste heat is available 300 kilowatt. उसका exergy पूछ रहा है. What is the exergy या available energy of the waste heat? Heat का available energy कितना होता है बच्चों? Available energy of heat is nothing but Q into 1 minus the ambient temperature, means TO, divided by the temperature of the heat. The temperature of the heat is going to decide how much exergy that heat is having. So available energy of a heat is nothing but Q into 1 minus TO by T higher. So here if you will do this exercise, 300 into 1 minus the atmospheric temperature is 25 degrees Celsius, so it is 298 Kelvin. The temperature of the heat is 600 Kelvin degrees Celsius, so 600 plus 273, it is 873. Temperature आपको Kelvin में use करना पड़ेगा. If you will carry out this calculation, you will get the available energy of waste heat. You will get the available energy of the waste heat, guys. Yes or no? Easily you will get the available energy of the waste heat. ठीक है बच्चों? Yes. See how C is not right, guys. You're making some kind of mistake. Option A is the right answer. 197.6 kilowatt. This is the right answer. C कैसे आ गया? सुशील कुछ गड़बड़ कर रहे हो आप? Option A is the right answer, guys. Option A is the right answer. Ravi, your answer is also right. बिल्कुल सही, guys. चलो next move करते हैं next question पे. ये common data question था बच्चों. ये common data question था. इसी क्वेश्चन में पूछ रहा आपसे the waste heat from the source given in the above problem. जिस प्रॉब्लम में waste heat आपको दी थी, कितना था waste heat बच्चों? Waste heat था 300 किलोवाट. ये waste heat था. ओके, इन द गिवन प्रॉब्लम 20th प्रॉब्लम, जो 20th प्रॉब्लम में जो सेम प्रॉब्लम था उसको हम एक्सटेंड कर रहे हैं. दिस वेस्ट हीट इज यूज्ड टू हीट ए प्रोडक्ट. द वेस्ट हीट व्हिच इज अवेलेबल, दिस वी आर यूजिंग टू हीट ए प्रोडक्ट. ओके, बाय एब्जॉर्बिंग 65 ऑफ दिस वेस्ट हीट. आपने उस हीट का 65 एब्जॉर्ब कर लिया है. 60 कितना हीट एब्जॉर्ब है बच्चों? हीट एब्जॉर्ब इज इक्वल टू 300 मल्टीप्लाई बाय 65. इसका 65% कितना आ जाएगा? कितना आएगा, इट विल बी 195 किलोवाट, है ना, यू कैन चेक, दिस विल बी 195 किलोवाट, ठीक है। The 65% of this much of the heat you are absorbing, 195 kilowatt you are absorbing, the rest is lost. The product of the temperature, जो प्रोडक्ट है जिसको आप एब्जॉर्ब करवा रहे हो, उसका टेम्परेचर इज रेज्ड टू दिस, means that product is initially at the initial temperature of the product is 25 degrees Celsius room temperature, the final temperature of the product is 150 degrees Celsius. So this heat which you are absorbing, this is available, this is now available at a temperature of the product which is at a temperature 150 degrees Celsius. Are you getting the idea? So you are utilizing the waste heat you are absorbing. Where you are absorbing? The waste heat is absorbed by some kind of body, okay, some kind of product, okay. That body is absorbing that heat, and due to that absorption of heat, the temperature of the body is increased to 150, raised to, not raised by, raised to 150 degrees Celsius. So, and how much heat this body is absorbing? It is absorbing 65% of the waste heat. So waste heat available is 300 kilowatt. 300 kilowatt means 65% you absorb. So now you are having this much heat available in the block. The block in which you are absorbing the heat, that heat is which is available to you is what? The amount of heat, the magnitude of heat is 195, and the heat is available at temperature this. Now he is asking you the exergetic efficiency. आपसे exergetic efficiency पूछ रहा है. Can you answer this question, guys? बहुत interesting question है ये. They are asking you the exergetic efficiency. So let me give you hint, guys. देखो exergetic efficiency का मतलब क्या होता है? Second law efficiency. How much exergy you are having now? कितना exergy आपने expand किया? देखो waste heat था. Waste heat के पास कितना exergy था? Waste heat के पास कितना exergy था भाई guys? 197.6. इतना एक्सर्जी था वेस्ट हीट के पास बच्चों, इतना एक्सर्जी था वेस्ट हीट के पास. This much heat, this much exergy is available with the heat. So this is the exergy we expended. ये एक्सर्जी हमारे पास अवेलेबल था. But how much we have utilized? कितना हमने यूटिलाइज कर लिया? We have absorbed some heat in the product, and now that product is at a temperature this. So don't say this is 195, because 195 is not the exergy. This is not work. This is heat only, because the heat which you are absorbing in the block, that is also heat. What is the exergy of that heat? उस heat का exergy कितना होगा बच्चों? So this is exergy you have expended, and how much exergy you have utilized is nothing but 195 into 1 minus the atmospheric temperature, means 298, divided by the temperature of the product. What is the temperature of the product? 150 degrees Celsius. Okay, 150 degrees Celsius. So 150 plus 273, this is the exergy. अभी बच्चों आपको समझना क्या है? This is exergy which is available with us now. This is exergy which is available in the block. This is the exergy which is available inside the block. This is exergy we expended, and the ratio of exergy we have utilized means exergy which is available with us and how much exergy we expanded in that project, okay, in that particular task. So that ratio is nothing but exergetic efficiency. तो इसको solve करोगे, you will get the answer. तो ये बहुत अच्छा क्वेश्चन है जो आपको समझना है. Is that clear, guys? Very very good question related to exergy. Is that clear, guys? Got the idea? बिल्कुल सही. जिनका 29 आंसर आ रहा है, they are very right. Option B is the right answer for this question. So you need to get some idea. आपको आइडिया लेना पड़ेगा, सोचना पड़ेगा. सेकेंड लॉ एफिशिएंसी क्या होगा? I think you are now, guys, it is very simple, very simple. I suppose you are having a air, hot air at some temperature, suppose 600 Kelvin. So how much exergy is available with that heat air? You can easily find out how much heat is there inside the air into, like suppose if it is at a constant temperature, if that reservoir is at a constant temperature, ठीक है, अगर वो किसी constant temperature पे है. But अगर constant temperature नहीं होगा, then there must be some kind of difficulty, and that case also we are going to discuss. Guys, these are the efficiencies, these are the expressions. मैंने यहाँ लिखे हैं, देखो कुछ. These all are the expressions. Second law efficiency के लिए these are the expressions. To find out the exergetic efficiency. Second law efficiency, how to write it for work producing device, how to write it for work absorbing device, how to write the exergy in terms of exergy. देखो सिंपल सा केस देता हूं बच्चों, मैं आपको एक सिंपल सा केस देता हूं. Like suppose you are having a light bulb. लाइट बल्ब है, उसका अगर आपको एक्सर्जेटिक एफिशिएंसी निकालना है, यू वांट टू फाइंड आउट द एक्सर्जेटिक एफिशिएंसी ऑफ द लाइट बल्ब, तो लाइट बल्ब में हाउ मच एक्सर्जी यू आर एक्सपेंडिंग, कितना एक्सर्जी आप खर्च कर रहे हो। मान लीजिए दैट बल्ब इज ऑफ 100 वॉट, तो कितना आपने खर्च किया एक्सर्जी 100 वॉट। अब उस बल्ब से that heat which is liberating from that bulb that you are using to heat some kind of suppose air, अभी अभी तो उसका एक्सर्जेटिक एफिशिएंसी जीरो। द बल्ब विच इज देयर इनसाइड द रूम, अगर आपसे कोई पूछे उसका एक्सर्जेटिक एफिशिएंसी क्या जीरो है सर, व्हाई, because we are not utilizing the heat, like we are getting some kind of comfort because we are able to see, लाइट ले रहे हैं और लाइट से हम देख पा रहे हैं, but it doesn't mean the exergetic efficiency is some value. If you are not utilizing the heat coming out from the bulb, it means the efficiency is zero. The second law efficiency for any bulb is zero. But if you will do a very simple exercise, if you will put that bulb in a kind of small enclosure to heat some kind of patties or some kind of samosas if you are having, so if you will put that bulb in a kind of container to heat some kind of content, to heat some kind of air, so suppose air you are having and the heat available with that air also you will be easily able to find out. So the heat available with the air multiply by 1 minus the atmospheric temperature divided by the temperature at which that heat is available, that is the exergy which is available with you. But how much exergy you expended, that is 100 watt, and that ratio, how much exergy is available with you, how much exergy you expended, that ratio is known as second law efficiency in terms of exergetic efficiency. Got the idea guys? तो इट डिपेंड्स, ठीक है। लाइक बल्ब है, अगर आपने उसको ओपन रूम में लगा दिया तो एक्सर्जेटिक एफिशिएंसी विल बी व्हाट, इट विल बी जीरो। So it depends how actually like you are utilizing the exit or not. Like suppose if you will take a kind of wind turbine, या अगर आपको कोई मिल जाता है, suppose if you will take a motor. So for motor, what is the output? The output is a mechanical work. Okay. What is the input? How much exergy you are expending? So the exergy expended is what? The power which you are giving. So suppose you are having a motor of suppose 1 kilowatt. So 1 kilowatt is the exergy we are expending. What is the shaft power? T into omega, that you can easily measure. The shaft power, if you will measure T into omega, that is the exergy which is available with us now. Okay. And that ratio is second law efficiency. Now you will be surprised. So that is similar to first law. And yes, that is a case, that kind of case can also be happen. Like first law efficiency can also be equal to second law efficiency. And motor is the case. For motor, both first law and second law efficiencies are same. Because in motor there is no heat. There is like we are giving work and we are getting work. There is a conversion of electric energy into work only. We are losing some kind of work in the form of heat only, because due to the friction between the various parts we are losing heat. So exergetic efficiency for the motor, you can write something like this. आप उसको ऐसे भी लिख सकते हो. Exergetic efficiency for motor is 1 minus irreversibility divided by exergy expended, exergy in. तो इसको आप ऐसे भी लिख सकते हो, या आप इसको ऐसा भी लिख सकते हो, W mechanical out, W mechanical divided by W electrical. Okay, because this irreversibility is nothing but W electrical minus W mechanical divided by W electrical. Yes or no? तो यहां से भी, because this is what, ये क्या है आपका, यहां से भी आप ऐसे लिख सकते हो. Okay, because यहां से heat lost, how much is the irreversibility in the motor? The irreversibility is nothing but the heat lost, Q lost into TO. Irreversibility equal to heat lost into TO. Okay, और कितना heat lost आप करोगे, the heat loss will be equal to what, the difference of the mechanical work minus what, the electrical work. तो it depends, ये depend करेगा कैसे आप इसको लिख रहे हो. ठीक है. So for different devices you can write the second law efficiency. ठीक है. तो मोटर के लिए, for motor, first law equal to second law efficiency. किसके लिए? for motor. मोटर के लिए दोनों क्या हो जाएंगी, सेम हो जाएंगी. बट दिस इज नॉट राइट फॉर व्हाट, इंजन के लिए सही नहीं होगा. इंजन के लिए क्या है, फर्स्ट लॉ एफिशिएंसी इज डिफरेंट, लाइक द W नेट डिवाइड बाय हीट सप्लाइड. फॉर इंजन, हीट इंजन के लिए द फर्स्ट लॉ एफिशिएंसी इज W नेट divided by heat supplied, and the second law efficiency is nothing but W net actual divided by W net maximum. This is second law efficiency for engine, and both are different. इंजन के लिए दोनों क्या होंगी, ये डिफरेंट होंगी. Got the idea guys? For some devices they are same. चलिए नेक्स्ट पे मूव करते हैं. क्वेश्चन नंबर दिस, दोनों पार्ट्स हमने इसके सोल्व कर लिए हैं. Both parts we have solved, so the efficiency you are going to get in the range of 29%. Next, 1 marks question in front of you. There are two cyclic heat engines. There are two cyclic heat engines. Okay. Yes, Shubham, it will be right for wind turbine also. A and B. A receives 500 kilojoule of heat from 800 Kelvin source, reject 300 kilojoule to a 400 Kelvin sink. Engine B receives 650 kilojoule of heat from a 1000 Kelvin source, reject 300 kilojoule to a 298 sink. Which one is right? तो चार ऑप्शन है आपके पास, बोल रहा है कौन सा स्टेटमेंट करेक्ट है. बहुत टिपिकल क्वेश्चन है और बहुत इजी क्वेश्चन है, इजीली यू कैन आंसर. ये इंजन है ए, ये है बी, ये है बी, ये 800 केल्विन सोर्स से हीट ले रहा है कितना, 500 किलोजूल, 500 किलोजूल, रिजेक्ट कर रहा है 300 किलोजूल टू ए सिंक एट 400 केल्विन. तो वर्क कितना है इसका, 200 किलोजूल, 200 किलोजूल. ये जो है बी, दिस इज टेकिंग 650 किलोजूल from a sink source at 1000 Kelvin, rejecting heat 300 kilojoule to a sink at 298 Kelvin. तो इजीली यू कैन चेक, दोनों को इजीली चेक कर सकते हो. कैसे? आपको चेक करना है साइक्लिक इंटीग्रेशन dq by t, it will less than equal to 0. इससे चेक करना है. You need to check this using this cyclic integration dq by t less than or equal to 0. Okay, रिवर्सिबल है या नहीं है. Okay, although you can check it from efficiency also. देखो इसका reversible efficiency कितना है. What is the reversible efficiency? Reversible efficiency is 50%. You can get idea. 1 minus t lower by t higher. That this is 400, this is 800. So 1 minus 400 by 800. So this was 50%. But इसका actual efficiency कितना है? Actual efficiency. The actual efficiency is what? This is only the W net. W net कितना है? 200 divided by 500. So this is 2 by 5 means 40%. It is less than that. So this is not a reversible engine. It is irreversible engine. A is irreversible because actual work efficiency is less than the reversible efficiency. Actual efficiency is less than the reversible efficiency. Okay. W net 200. ये हमने 200 कैसे लिख लिया? एनर्जी बैलेंस से. 500 ये 300 है तो डिफरेंस कितना होगा? 200. This is W net. Q1 minus Q rejection. Addition minus rejection is W net. 200. फर्स्ट लॉ से हम लिख सकते हैं ऐसे. एंड एफिशिएंसी इज नथिंग बट W net डिवाइड बाय हीट सप्लाई. 200 डिवाइड बाय 5, सो 40%. इसका मतलब क्या है? 40%. सो मींस इंजन ए इज इरिवर्सिबल. इसी तरह से यहां भी निकाल सकते हो आप. देखो रिवर्सिबल एफिशिएंसी कितना है? रिवर्सिबल एफिशिएंसी इज 370%, क्लोज टू 70%. यस और नो? रिवर्सिबल एफिशिएंसी इज क्लोज टू 70%. कैसे कह सकते हो सर ये क्लोज टू 300 है? 300 by 1000, 1 minus 300 by 1000, that is close to 70%. What is actual efficiency? Sir, actual efficiency also we can write actual efficiency. इससे करना है तो इससे भी कर सकते हो. You can check it from here also. अगर ये if it is coming out equal to 0 means that engine is reversible. If it is coming out less than 0 means engine is irreversible. You can check it from here also. Closest inequality से भी कर सकते हो बच्चों. बट मैंने ऐसे पहले किया था तो दैट्स व्हाई हियर आई एम यूजिंग दिस डायरेक्ट रिलेशनशिप एफिशिएंसी. तो इट्स अप टू यू. तो वर्क कितना हो जाएगा? द वर्क इज 650 minus 300, इट इज 350 किलोजूल. तो इसको पुट कर दो 350 डिवाइड बाय 650. तो इसकी भी जो एक्चुअल एफिशिएंसी आएगी, दिस इज लेस देन एफिशिएंसी ऑफ रिवर्सिबल. दिस इज फॉर बी एंड दिस इज फॉर ए. तो दोनों ही क्या हो जाएंगे? बोथ आर इरिवर्सिबल. अकॉर्डिंग टू मी आई थिंक बोथ आर इरिवर्सिबल. ठीक है, बोथ क्या है? बोथ आर इरिवर्सिबल. ठीक है, तो डी क्या हो जाएगा? डी इज द आंसर फॉर दिस क्वेश्चन. बोथ आर इरिवर्सिबल बिकॉज एफिशिएंसी ऑफ बोथ द इंजन्स इज लेस देन द एफिशिएंसी ऑफ रिवर्सिबल इंजन. एफिशिएंसी अगर रिवर्सिबल से कम है इट मींस इंजन इज इरिवर्सिबल. अगर इक्वल होती तो हम बोलते कि वो इंजन क्या है? रिवर्सिबल है. ठीक है, चलिए, otherwise you can check that also. Next question guys in front of you. So heat transfer occurs steadily from a furnace to the surrounding across a wall at a rate of 1 kilowatt. So यहां से heat transfer हो रहा है बच्चों. Heat transfer हो रहा है at a rate 1 kilowatt. heat transfer कितना है 1 kilowatt as shown in the diagram. The temperature of the inner surface is 700 degrees Celsius, the outer surface is 100 degrees Celsius. Find the rate of entropy generation. Rate of entropy generation, बहुत अच्छे कंसेप्ट यहां से हम डिस्कस करने वाले हैं बच्चों. We are going to discuss very important concept related to entropy balance. How to solve these kind of problems using entropy balance. So can you answer this question, guys? There is a heat transfer through a wall. The heat transfer is 1 kilowatt from inner surface temperature 700 to the outer surface temperature 100 degrees Celsius. He is asking you the entropy generation. Chalo. Guys, you know entropy generation, delta S generation is nothing but entropy change of system plus entropy change of surrounding. ऐसे लिखते हैं एंट्रोपी चेंज ऑफ सिस्टम प्लस एंट्रोपी चेंज ऑफ सराउंडिंग, ऐसा लिख सकते हैं. यू कैन यूज दिस कंसेप्ट और यू कैन राइट द एंट्रोपी बैलेंस आल्सो. एंट्रोपी बैलेंस क्या होता है? एंट्रोपी इन माइनस एंट्रोपी आउट प्लस एंट्रोपी जनरेशन इक्वल टू चेंज इन एंट्रोपी ऑफ द सिस्टम या कंट्रोल वॉल्यूम. रेट की टर्म में लिखना चाहो तो रेट की टर्म में भी लिख सकते हो. रेट ऑफ एंट्रोपी इन, रेट ऑफ एंट्रोपी आउट प्लस रेट ऑफ एंट्रोपी जनरेशन, that is equal to rate of entropy change of the control volume. Something like this you can write. ठीक है. So this is our system. ये हमारा सिस्टम है. This is our system. यहाँ पे टेम्परेचर 700 है, यहाँ पे टेम्परेचर कितना है 100 है. So what is entropy in? कितना एंट्रोपी एंटर कर रही है? Guys, when heat is entering, heat is having some kind of entropy association with it. वर्क के साथ कोई एंट्रोपी एसोसिएशन नहीं होता. वर्क इज ए हाई ग्रेड एनर्जी, but heat is having some kind of entropy association with it, and the entropy of the heat is nothing but, heat का entropy कितना होता है बच्चों? Entropy of heat, heat के साथ entropy हम कितना लिखते हैं? Entropy of heat is nothing but Q by T. Entropy of the heat is equal to Q by T. So how much is the entropy in? That is equal to Q by T, means 1 kilowatt divided by the temperature at which heat is entering. So it is 700 plus 273. This is entropy in. What is entropy out? The entropy out is same. 1 kilowatt is the heat out, because in steady state, the heat in equal to heat out. The heat in is equal to heat out. In steady state, heat in equal to heat out, the steady state. So this is 1 by, at which temperature heat is going? It is at 100 temperature. So 100 plus 273.15. Okay, चलो 273 कर लेते हैं. So this is entropy in, this is entropy out, plus entropy generation, plus entropy generation, rate of entropy generation. This is equal to the change in entropy of the control volume. This will be zero, guys, in case of steady state. ये जीरो कब होगा बच्चों? स्टेडी स्टेट में. In steady state, what is steady state? Steady state means the properties of the system are not going to change with the time. The properties of the system are not going to change with time. Means the system which you are having, the control volume which you are having, the heat in equal to heat out. Okay, energy which is entering, that is equal to energy which is going. So the properties of the control volume, they are not going to change. So entropy of the control volume are not going to change with time. So this term is zero. किसके लिए? The change in entropy with the time of the control volume is zero in case of steady state. किसी भी steady state में ये term क्या होती है? Zero होती है. So from this directly you can write entropy generation equal to कितना? 1 by 100 plus 273 minus 1 by 700 plus 273. From this you will get the entropy generation directly. यहां से आपका entropy generation आ जाएगा. From this you will get the entropy generation, but you need to be very careful using temperatures in Kelvin. Temperatures को डिग्री सेल्सियस में यूज मत करना बच्चों. You need to use these temperatures in Kelvin. Okay, you can ask me, sir, we are not very much aware about this, we want to use this. हमें तो ये यूज करना है सर, ये समझ में आता है हमारे. We are very much comfortable with this. Entropy generation is nothing but change in entropy of the universe, entropy change, और इसको हम बोलते हैं net entropy change, total entropy change, entropy change total, entropy generation, entropy change of the universe, total entropy change. That is nothing but entropy change of system, rate of entropy change of the system plus rate of entropy change of the surrounding. Rate of entropy change of the system plus surrounding. For system it will be zero. Why? Why the entropy change of the system will be zero? I told you in steady state, the entropy change of the system will be zero. Whatever energy is entering, that is equal to energy leaving. So entropy change of the system will be zero. So entropy generation, in this case, the rate of entropy generation will be equal to entropy change of the surrounding. So surrounding क्या है बच्चों? Surrounding is what? Initially you are taking heat. heat addition from the surrounding, so this will be negative. The entropy change of the surrounding this side, that will be negative. Why? Because you are taking heat from the surrounding. So minus 1 kilowatt divided by 700 plus 273. This is negative. Why negative, guys? Entropy change of the surrounding. You are taking heat from the surrounding. So what is the entropy change for the source? That will be minus Q by T. What is the entropy change for the sink? It will be plus Q by T. 1 by 100 plus 273. तो ऐसे करो, in both the cases you are going to get the same answer. It's totally up to you how you want to solve this problem. ठीक है बच्चों, तो मैंने आपको दोनों तरीके बता दिए हैं. If you are interested with this simple basic approach, you can apply this also. Okay, you can apply this also. Otherwise I told you how to solve it with this system. Okay, तो system का ये क्या हो जाएगा? It will be 0. यहाँ लिख देता हूं मैं, it will be 0. Got the idea, guys? Is that clear? Is that clear, guys? How to solve it with this approach? System plus surrounding. Okay, सिस्टम प्लस सराउंडिंग से करना है तो तब भी यही आंसर आ जाएगा, या अगर एंट्रोपी बैलेंस से करना है तो ये भी आंसर आ जाएगा. बट मेरे ख्याल से दिस इज वेरी मच इजी. यहां से आप बहुत सारी प्रॉब्लम्स को घुमा सकते हो. वहां पे थोड़ा सा कंफ्यूजन हो जाता है व्हेन द प्रॉब्लम्स आर कंपैरेटिवली कॉम्प्लेक्स. तो विदाउट एंट्रोपी बैलेंस देन समटाइम वी फेस सम काइंड ऑफ डिफिकल्टी in writing the entropy change of system plus surrounding. Although that approach is also fine, if you are comfortable with that, then that also you can apply in most of the problems. ठीक है, चलिए नेक्स्ट प्रॉब्लम पे मूव करते हैं बच्चों. अभी आपको बोल रहा है सेम प्रॉब्लम है. इन द सेम प्रॉब्लम व्हाट ही डिड, उसने बोला फॉर द अबव प्रॉब्लम इफ यू विल कंसीडर द हीट ट्रांसफर इफ द फर्नेस इज मेंटेन्ड एट दिस. अभी वो बोल रहा है कि फर्नेस से कंसीडर करो, वॉल से नहीं, फर्नेस से लो. ये जो केस था ना, ये केस. So the furnace is at 800 degrees Celsius, furnace is at 800 degrees Celsius and the sink is at 25. इन दो टेम्परेचर्स को लो. The furnace is at 800, the sink is at this. देखो इसको बच्चों आप सोल्व करोगे, आंसर मैं आपको बता देता हूं. सो इसका जो आंसर था 1.65. सो अगर आपका बी आंसर आया था पहले वाले पार्ट का 23 के लिए बी इज राइट. फॉर 23 बी इज द राइट आंसर. 1.65 वाट पर केल्विन. ठीक है. इन सेकंड पार्ट ही इज आस्किंग यू द सेम एंट्रोपी जनरेशन, एंट्रोपी चेंज पूछ रहा है. फॉर द सेम प्रॉब्लम फाइंड द रेट ऑफ द टोटल एंट्रोपी जनरेशन. मींस एंट्रोपी जनरेशन, net entropy change of the universe, all things are same. But this time he mentioned consider the furnace temperature 800 and the surrounding temperature this. So again you can write it something like this. Entropy generation is nothing but system plus surrounding. System plus surrounding. In steady state the system will be 0, the surrounding it will be minus 1 divided by 800 plus 273 plus 1 divided by 25 plus 273. तो ऐसे आप डायरेक्टली लिख सकते हो. दिस इज द रेट ऑफ एंट्रोपी जनरेशन. दिस इज रेट ऑफ एंट्रोपी जनरेशन. 1 by 800 plus 273 plus 1 by 25 plus 273. you will get the answer. ठीक है बच्चों. So if you will solve this, you will get the answer 2.42. 2.42. और from entropy balance also you can write the answer. Entropy balance से भी आप लिख सकते हो guys. From entropy balance also you can write the answer. 2.42 watt per Kelvin is the right answer for this question. Let's move to next question. Question number 25. Okay, चलिए. Don't worry about the length, guys. Don't fear from the content of this question. You need to read and you need to answer. There is a student living in a room 4 meter into 6 meter into 6 meter. बहुत बड़ा रूम है यार. ये तो रूम कहाँ है? ये तो पूरा हॉल है. 4 into 6 into 6 dormitory room turns on her 200 watts fan before she leaves the room on a summer day, hoping that the room will be cooler when she comes back in the evening, assuming all the doors and windows are tightly closed and disregarding any heat transfer through the walls and the windows. Determine the temperature in the room when she comes back 8 hours later. Use specific heat value at the room temperature. Assume the room to be 100 kilopascal, 27 degrees Celsius in the morning when she leaves. Given the R value for the air is 0.287 kilojoule per kg Kelvin. वही unit आ जाएंगे if you will check. CV is 0.718. So he's asking you the final temperature. Okay. फाइनल टेम्परेचर, द टेम्परेचर इन द रूम विच यू आर गोइंग टू गेट इन द इवनिंग। तो कैसे निकालोगे बच्चों? क्वेश्चन क्या है, ये रूम है, ये रूम है आपका, बहुत बड़ा रूम है। कितना वॉल्यूम है इस रूम का? द वॉल्यूम इज 4 into 6 into 6 meter cube. This much meter cube. This is the volume of the room. Okay. This much is the volume of the room. So, you know the pressure, you know the volume, mass, RT. तो यहां से आपके पास mass of air आ जाएगा. You will get the mass of the air inside the room. Okay. You will get the mass of the air inside the room. PV equal to MRT. Pressure is known 100 kilopascal. Volume is known. R is known 0.287. Temperature is known. Okay. इनिशियल टेम्परेचर, तो यहां से मास ऑफ द एयर इनिशियल आ जाएगा, यहां पे लिख लो P इनिशियल है, वॉल्यूम तो सेम ही रहेगा, R क्या है आपका? इनिशियल टेम्परेचर. ओके, initial temperature. If you use the initial temperature, you will get the mass of the air initially. The room is closed, it is sealed actually, so the mass of the air is not going to change. Don't worry sir, that mass will remain constant, obviously, because the room is properly insulated, so there is no heat transfer from the outside, there is no leakage, we are assuming. बाहर से कोई भी हीट ट्रांसफर नहीं हो रहा है, there is no heat transfer, there is no mass transfer, so the mass of the air inside this is constant. Okay guys, so what you are doing, आपने एक फैन चलाया, इस बच्चे ने क्या किया, एक फैन चलाया, so this is a fan, ये फैन चलाया इसने, so this fan is of 200 watts, 200 watts का ये फैन चलाया for 8 hours and he is asking you the final temperature. तो बहुत सिंपल क्वेश्चन बन जाएगा बच्चों. So how much is the heat transfer? If you will assume the 100% efficiency of this fan, so whatever work we are supplying, that is going to convert into the heat. So heat in, आप ऐसे भी लिख सकते हो, you can write it something like this, dq equal to du plus dw, dq equal to du plus dw. So suppose this room is insulated, so dq is 0, this is du, work is minus 200 watt into 8 hour into 60 into 60, because we want this in joule. अपने को एक किसमें चाहिए? जूल में. We want this in joule. So this is the work done on the system. The air inside the room is our system, and we are doing work, because fan is a kind of system which is converting electrical energy into mechanical work only. So it's a kind of, you can assume it is a kind of pedal wheel case. So you are doing some work on the gas air. So that will be 200 watts का fan है. So converting this into joule, you need to आपको क्या करना पड़ेगा? Multiplied with 8 hour into 60 into 60. तो ये किस में आ जाएगा? जूल में आ जाएगा. Okay, so du which is equal to m cv dt equal to 200 into 8 into 60 into 60. What is change in internal energy for an ideal gas? This is change in internal energy for the ideal gas. So the mass of the air, Cp is 718. जूल में यूज करना पड़ेगा बच्चों, because this is in joule. ये किस में है? This is in joule. तो ऐसा यूनिट्स का ध्यान रखना. If you are using this, putting this in joule, otherwise you can divide it by 1000 to get this in kilojoule. या तो इसको 1000 से divide कर दो, so that you will get this in kilojoule. Then you can use it here 0.718. Okay. Otherwise you need to use here 718. 718. Okay. चलिए, into T final minus T initial into this entire information, easily you will get the final temperature. बहुत हलवा क्वेश्चन था बच्चों, अगर आपके समझ में आया तो this question is very easy. Initial temperature is given to you 300 Kelvin. The initial temperature is, the T initial is 300 Kelvin. 27 मतलब 300 Kelvin. Yes, what answer you are getting guys? What answer you are getting for this question? What is the final temperature inside the room? Yes, option D क्या हो जाएगा? This is the right answer. Option D, 75 degree Celsius is the right answer for this question. बिल्कुल सही बच्चों, very good. चलिए अगला क्वेश्चन है, मूव करते हैं. 26th. There is a rigid container equipped with a steerer device containing 0.5 kg of the motor oil. Determine the rate of internal energy increase per unit mass when the heat is transferred to the oil at a rate of 1.5 watt and 2 watt of power is applied to the steering device. So very simple question guys, बहुत आसान question है. This easily you can write because it is a kind of closed system. So dq equal to du plus dw. How much is the heat transfer? heat added to the system. When heat is transferred to the oil is this, means this much is the heat added to the system, 1.5 watt. du plus work done on the system, so it will be minus 2 watt. It will be minus 2 watts. So du will be 3.5 watts. Okay, du will be 3.5 watts. Okay, और du क्या होता है बच्चों? He is asking you the change in internal energy. अब ये किलोवाट में होना चाहिए, तो इसमें करेक्शन कर लेना बच्चों, ये 1.5 आंसर नहीं आएगा, तो दिस विल बी 1.5 किलोवाट, दिस विल बी 2 किलोवाट, 1.5 kilowatt and 2 kilowatt. ये करेक्शन कर लेना, otherwise you will not get the answer. This is 1.5 kilowatt, this is 2 kilowatt. Okay, so this I'm writing it in kilowatt. Okay, so he's asking you the change in internal energy, per unit mass, increase in internal energy per unit mass. So du will be 3.5 divided by mass, which is 0.5. So the answer will be 7 kilowatt per kg. The answer will be 7 kilowatt per kg. The mass is 0.5 kilojoule. The mass is 0.5 kilojoule. So answer आएगा 7 kilowatt per kg, not 7 kilojoule per kg. Watt में answer आएगा ना बच्चों? Why you are answering D? Note D. Note D, guys. B will be the right answer. B will be the answer for this. आप units कैसे change कर सकते हैं? किलोवाट को आपने जूल कैसे बना दिया? D is not right. B is the right answer, guys. B is the right answer for this question. Kilowatt per kg. The heat transfer is in kilowatt, the work transfer is in kilowatt. So the internal energy also you are going to get in kilowatt. 7 kilowatt per kg is the answer for this question. Next question. An insulated rigid tank initially contained 2 kg of helium at 40 degrees Celsius, 350 kilopascal. A paddle wheel with a power rating of 15 watt is operated within the tank for 30 minutes. Determine the final temperature and pressure of the helium gas. T temperature, final temperature पूछ रहा है आपसे और final pressure पूछ रहा है आपसे. Insulated tank है, rigid insulated tank है, means volume is constant. तो पहले टेम्परेचर निकाल लो, टेम्परेचर निकालोगे तो प्रेशर भी आ जाएगा, बिकॉज यू नो इफ वॉल्यूम इज कांस्टेंट तो क्या हो जाएगा, आपका एक्सप्रेशन विल बी P by T इक्वल टू कांस्टेंट. तो आप लिख सकते हो P इनिशियल बाय T इनिशियल इक्वल टू P फाइनल बाय T फाइनल. तो पहले T फाइनल निकाल लो, फ्रॉम दैट दिस रिलेशनशिप इजीली यू विल गेट P फाइनल आल्सो, बिकॉज वॉल्यूम इज कांस्टेंट. फॉर रिजिड इंसुलेटेड टैंक द वॉल्यूम इज कांस्टेंट. And how you will get the final temperature? Using this relationship, dq equal to du plus dw. Rigid insulated tank है तो dq will be 0, so du equal to minus dw. Okay, du equal to minus dw. You are doing work on the system, so minus into minus, work done on the system, so it will be minus into minus. 15 watt है तो 15 into, you are operating it for 30 minutes, so 30 into 60. This is du. Insulating, it's an argon. This is 2 kg helium. So for helium the CV is given to you. CV कितना है? 3.11. So 3.1156 किलोजूल है, तो मल्टीप्लाई करना पड़ेगा 10 की पावर 3. mCV dt. T final, this is T final minus T initial. What is T initial, guys? The T initial is 40 degrees Celsius, so 273 plus 40, it will be what? कितना आ जाएगा? T initial will be, देखो 273 plus 40 करोगे तो it will be 303 and yes 313.15. So solving this easily you will get the final temperature. यहां से इसको सोल्व करोगे तो T final आ जाएगा. T final को यहां पुट करोगे you will get P final. So based on that easily you can answer this question. Yes, please answer this simple question, guys. Gaurav का आंसर सबसे पहले आया है. Manoguma, your answer is also right. Option C is the right answer for this question. The final temperature will be 44 degrees Celsius. The final pressure will be 354 kilopascal. The final temperature, the final pressure will be something like this. चलिए नेक्स्ट क्वेश्चन पे मूव करते हैं बच्चों. These questions are nowadays very much famous in GATE XE examination, guys. They are asking much question from related to compressibility factor. बहुत सारे क्वेश्चन पूछ रहे हैं आजकल वो compressibility factor से. So similar type of question I found in the NPTEL assignments. Determine the specific volume of the superheated water vapor. Specific volume of the superheated water vapor at 40 megapascal 780 degrees Celsius using the ideal gas equation, using the generalized compressibility chart. Determine the वॉल्यूम. आपको क्या पूछ रहा है, मतलब एक तो स्पेसिफिक वॉल्यूम निकालना है, स्पेसिफिक वॉल्यूम आइडियल निकालना है, आइडियल निकालना, ये निकाल दो. एक स्पेसिफिक वॉल्यूम एक्चुअल निकालना है, दो निकालने हैं आपको, आइडियल एंड एक्चुअल. ठीक है, आइडियल एंड एक्चुअल. तो कैन यू फाइंड आउट गाइस, पहले का आंसर क्या होगा? आपसे डिफरेंस पूछ रहा है, ही इज आस्किंग यू द डिफरेंस एक्चुअली. तो आपसे पूछ रहा है द मैग्नेट. अच्छा, सिमिलर टाइप ऑफ क्वेश्चन आई थिंक दैट वाज आस्क्ड इन एक्सी आल्सो, गेट एक्सी में पूछा गया है. आई डोंट नो लाइक द डेटा कंटेंट अलग हो सकता है, बट सिमिलर टाइप ऑफ क्वेश्चन वाज देयर. ओके, सो ही इज आस्किंग द डिफरेंस बिटवीन द टू वैल्यूज. स्पेसिफिक वॉल्यूम ऑफ आइडियल मींस वी आइडियल माइनस वी एक्चुअल. इसका डिफरेंस पूछ रहा है आपसे, वी आइडियल माइनस वी एक्चुअल. देखो एक्चुअल तो आपके पास तभी आएगा इफ यू नो द कंप्रेसिबिलिटी फैक्टर. कंप्रेसिबिलिटी फैक्टर. ओके, आइडियल कहां से आएगा बच्चों? The ideal volume you will get from the ideal gas equation. The ideal volume you will get from the ideal gas equation. What is ideal gas equation? PV equal to MRT. Sorry, PV, capital V. Okay, this PV equal to MRT. Okay, or specific volume V equal to RT by P. What is R for water vapor? R for water vapor is nothing but 8.314 divided by molecular weight of water vapor. कितना होगा? H2O. So 16 प्लस 2 इट विल बी 18, तो 0.461 आ जाएगा. इट विल बी 0.461. अदरवाइज अगर आप भूल जाओ तो यूनिवर्सल गैस कांस्टेंट को मोलिकुलर वेट से डिवाइड कर दो. यूनिवर्सल गैस कांस्टेंट इज 8.314 डिवाइड बाय मोलिकुलर वेट ऑफ द वाटर व्हिच इज H2O. तो 16 प्लस 2 इट विल बी 18. तो इसको करोगे तो 0.461 आ जाएगा. इनटू टेंपरेचर. द टेंपरेचर इज कितना है? टेंपरेचर कितना है आपका? 780 डिग्री सेल्सियस. सो इट इज 780 प्लस 273. This is temperature divided by pressure. Okay. So when you are using this in इसको याद रखो, इसको आप किसमें यूज कर रहे हो बच्चों? This you are putting in kilojoule per kilomole. Kilojoule. This is in now it is in kilojoule per kg Kelvin because characteristic gas constant है. So this is in kilojoule per kg Kelvin. So the pressure you need to put in kilopascal. Pressure को किसमें पुट करना पड़ेगा? kilopascal में. 40 into 10 की power 3. 40 into 10 की power 3. I think you are aware about all those units, guys. When you are putting this in characteristic gas constant in kilojoule per kg Kelvin, so the pressure you need to put in kilopascal. ठीक है, अगर इसको पुट करोगे जूल पर केजी में, then you need to put this pressure also in न्यूटन पर मीटर स्क्वायर, मतलब पास्कल में. तो इसको पुट करोगे तो आपके पास V ideal आ जाएगा. This is nothing but V ideal. This is V ideal. Okay, और ये आएगा, this will come out close to 0.0012137 meter cube per kg. मीटर क्यूब पर केजी. दिस इज V आइडियल. यस गौरव, बिल्कुल सही. 0.0 अपने एक जीरो हटा दिया मेरे ख्याल से ना, 0.0012 आएगा. चेक करना गौरव. आई थिंक इट विल नॉट बी 0.012, इट विल बी 0.0012. ठीक है, चेक करना. चलिए, नाउ यू वांट आइडियल एक्चुअल वॉल्यूम. एक्चुअल वॉल्यूम कहां से आएगा बच्चों? अगर देखो आपको कंप्रेसिबिलिटी फैक्टर पता है, सो कंप्रेसिबिलिटी फैक्टर होता है which is also known as deviation factor. This is known as gas deviation factor. Compressibility factor. So compressibility factor is nothing but the actual volume of the gas divided by ideal volume of the gas. This compressibility factor is also known as gas deviation factor because this Z tells us about the deviation of a real gas from the ideal gas behavior. The deviation of a real gas from the ideal gas behavior. For ideal gas, Z for ideal gas is 1. For ideal gas, Z equal to 1 means V actual equal to V ideal. Okay, but if it is Z is far away from the 1 means the behavior of the gas is away from the ideal gas behavior. Okay, और ये अपने पास आता कहां से बच्चों? देखो मैं आपको एक चार्ट दिखाता हूं, मैंने यहाँ पे पुट लिया था, मैं आपको शो करता हूं चार्ट. ओके यहीं पे है। ओहो चलिए लेट मी पुट इट हेयर in front of you. Yes, there is chart. This chart is known as compressibility chart. Okay, this chart is known as compressibility chart. So here you are having z, यहाँ पे आपके पास क्या दिख रहा है z. Okay, so अगर ये z equal to 1 होता है बच्चों, z is equal to 1, ये z ये लाइन क्या शो कर रही है, z equal to 1 means this line straight line will be for ideal gas. Ideal gas के लिए आपको क्या मिलेगी, straight line. This is a graph between z versus reduced pressure. What is reduced pressure, guys? PR, reduced pressure, equal to P by P critical into T reduced equal to T by T critical. The temperature of a gas in comparison to its critical temperature. The pressure of a gas in comparison to its critical pressure, that is known as P reduced pressure and reduced temperature. What is PR? PR is a reduced pressure. The pressure of a gas relative to the critical pressure of that gas. मान लीजिए गैस है आपके पास किसी प्रेशर पे 100 किलो पास्कल पे, सो 100 डिवाइड बाय उसका क्रिटिकल प्रेशर, दैट इज नोन एज रिड्यूस्ड प्रेशर. Similarly, the temperature of the gas divided by its critical temperature, that is known as reduced temperature. तो अपने को ना जो गैस जो क्वेश्चन दिया है in that problem, he has given you reduced pressure and reduced temperature. मैं यहां लिख देता हूं, जो अपने को वाटर वेपर दिया था उसके लिए उसने पी क्रिटिकल दिया था, तो पी क्रिटिकल कितना था, यू नो दिस इज वाटर के लिए कितना होता है बच्चों, क्रिटिकल प्रेशर इज क्लोज टू 221 एटमॉस्फेरिक ना, या 22 मेगा पास्कल, इतना ही होता है वाटर के लिए. फॉर वाटर द प्रेशर क्रिटिकल प्रेशर इज 22.06 मेगा पास्कल. सिमिलरली व्हाट इज क्रिटिकल टेम्परेचर, इट इज क्लोज टू 374. ठीक है, 374 डिग्री सेल्सियस हो जाएगा, तो केल्विन में कितना हो जाएगा, 647.1 केल्विन. So this is critical temperature, this is critical pressure for the water. Water के लिए ये क्या है, critical temperature, critical pressure. तो easily you can find out P reduced and T reduced. अभी जो केस दिया है अपने को उसमें वाटर वेपर था किस टेम्परेचर पे बच्चों, वाटर वेपर का जो टेम्परेचर था वो था 40 डिग्री सेल्सियस, मतलब 3 कितना हो जाएगा 313 केल्विन, और प्रेशर था कितना, प्रेशर इज 40 मेगा पास्कल. तो ये तो प्रेशर टेम्परेचर दिए थे अपने को, these are the pressure temperature given and these are the critical pressure and critical temperature given. तो easily you can find out water का reduced pressure reduced temperature. देखो reduced pressure निकालोगे तो reduced कितना हो जाएगा, pressure कितना 40 divide by P critical, 40 divide by this 22.06, तो ये जितना आ जाएगा. सिमिलरली टी क्रिटिकल भी निकाल लो, टी क्रिटिकल भी निकालो बच्चों, यहाँ पे टी रिड्यूस, सॉरी टी रिड्यूस्ड भी निकालो, टी रिड्यूस्ड विल बी 313 डिवाइड बाय 647.1. तो अगर ये एक्सरसाइज आप करोगे तो रिड्यूस टेम्परेचर आ जाएगा 1.6274 और ये आ जाएगा आपका 1.8132, 1.8132 एंड दिस विल बी 1.6274. ओके, तो ये आपको मैं सिर्फ बता रहा हूं जस्ट फॉर योर अंडरस्टैंडिंग. इन गेट ही इज गोइंग टू गिव यू ऑल दोस डेटा, ठीक है, ताकि थोड़ा सा अंडरस्टैंडिंग डेवलप हो जाए. बाकी बच्चों अगर आप इस चार्ट को रेफर करते हो एट ए रिड्यूस्ड प्रेशर 1.8132, सो दिस इज रिड्यूस्ड प्रेशर 1.8132 close to this, so this is a line which is going to represent the reduced pressure. This line is going to represent the reduced pressure close to 1.8132. Similarly you will have a line which is going to represent the reduced temperature 1.6274. देखो this is representing, this curve is representing reduced temperature 1, this is representing reduced temperature 1.1, this is 1.2, this is 1.3, this is 1.5 and top one is this one is 2. ये वाली क्या है 2. तो इसके बीच में कहीं ना कहीं लाइन होगी ना कुछ ऐसे, इसके बीच में कहीं ना कहीं ऐसे लाइन होगी which is going to represent reduced temperature 1.6274. ओके, 1.6274. तो ये वाला पॉइंट कुछ यहाँ पे आएगा and at that point if you will check the compressibility factor, the Z will come out 0.9, the Z will come out close to 0.9. So guys, for these type of problems, first you need to check the reduced pressure, you need to check the reduced temperature. You can check that value from the graph also, some tabular form may also, if you are having some data then you can refer to that tabular form. Based on that TR, PR, you can find out the compressibility factor directly. So that I'm telling you, because that value they have not given in this problem, but in GATE they are going to provide you that data. what is the compressibility factor. Okay, I think now it is very clear. And some general question they can frame guys from this. You know, if the reduced temperature, देखो इस चार्ट में अगर आपका reduced temperature बहुत कम है 1 से, reduced temperature is very very less than 1, तो कोई भी गैस हो you will fall in this region guys, you will fall in this region. So the behavior of that gas will be very close to the ideal gas equation. So if reduced temperature is very very less than 1, so the gas will behave as a ideal gas, irrespective of pressure. एनी प्रेशर कुछ भी हो, रिड्यूस्ड प्रेशर कुछ भी हो बच्चों, अगर आपके पास कोई गैस है एट ए टेम्परेचर at a reduced pressure at a reduced pressure PR, if you are having a gas at a reduced pressure less than 1, because this is the line guys, this is a line for reduced pressure 1. So if you are having a gas at a reduced pressure less than 1, irrespective of the temperature, you are having temperature, reduced temperature 1, reduced temperature 1.1, 1.2, any value, you will be very close to the ideal gas equation. So if reduced pressure is very very less than 1, the behavior of the gas will be ideal gas irrespective of temperature. Irrespective of temperature, the behavior will be ideal gas behavior. दूसरा क्या है, अगर reduced temperature क्या है, if it is close to 2, अगर ये close to 2 है, ठीक है, या आप बोल लो कि ये क्या है, what is this, close to 2, reduced temperature is close to 2. और इसमें दूसरा केस क्या है कि जो reduced pressure है वो बहुत हाई नहीं होना चाहिए, not very high, except PR not very high. reduced temperature close to 2 हो और reduced pressure क्या हो, बहुत ज्यादा ना हो, because अगर reduced pressure बहुत ज्यादा हो जाता है ना बच्चों, तो ये जो कर्व है ना, ये कुछ ऐसे चली जाती है, ये जो कर्व है ये कुछ ऐसे हो जाती है, ऐसे. चलो मैं इसको हटा देता हूं so that you will get idea. मैं यहां लिख देता हूं. So if you are having reduced pressure very very high, देखो ये तो reduced pressure यहां तक है, up to 4.55 तक, 4.55 तक कोई दिक्कत नहीं है, बट अगर reduced pressure इससे भी ज्यादा होता है ना, तो ये लाइंस कुछ ऐसे डेविएट कर जाती हैं ऊपर. तो कंडीशन क्या है, reduced temperature close to 2 और reduced pressure क्या है, ये बहुत ज्यादा हाई नहीं होना चाहिए, एक्सेप्ट ये, तब भी क्या होता है, आपके पास आइडियल गैस बिहेवियर होता है, आइडियल गैस बिहेवियर. ओके, आइडियल गैस बिहेवियर. तो ये पहला कंक्लूजन हमने निकाला. पहला कंक्लूजन क्या निकाला, रिड्यूस्ड प्रेशर लेस देन 1, बहुत कम है, कम से 1 से, तो आप यहां पे होंगे तो गैस बिहेवियर विल बी क्लोज टू आइडियल गैस बिहेवियर. दूसरा कंक्लूजन निकाला, रिड्यूस्ड टेम्परेचर क्लोज टू 2 एक्सेप्ट PR बहुत ज्यादा हाई नहीं होना चाहिए, PR not exceptionally not very high. This is the second conclusion. Then also you will get ideal gas equation. और तीसरा कंक्लूजन क्या है इसमें, दिस इज फर्स्ट कंक्लूजन, ये पहला था, ये सेकंड था, और तीसरा कंक्लूजन क्या है बच्चों, अगर आपका गैस होती है क्रिटिकल पॉइंट के आसपास, क्रिटिकल पॉइंट पे व्हाट इज TR गाइस, क्रिटिकल पॉइंट पे एट क्रिटिकल पॉइंट T equal to T critical, P equal to P critical, TR will be 1, PR will be 1, yes or no. If you are having a gas at a critical point, so TR will be 1, PR will be 1. तो where you will lie, कहां पे लाई करोगे आप, देखो अगर आप इस डायग्राम को देखते हो, you will be somewhere here, यहां पे, because this is the line, this is the curve which is representing TR equal to 1, this is the point which is representing PR equal to 1. तो आपको क्या चाहिए, PR equal to 1, PR equal to 1, TR equal to 1. So you will be very very far away from the ideal gas equation. So if you are having a gas away from the, generally बच्चा सोचता है कि गैस अगर क्रिटिकल पॉइंट पे है, मतलब गैस तो बहुत हाई टेम्परेचर पे है, बहुत हाई प्रेशर पे है, so the behavior will be close to ideal gas equation. That is not right guys, that is wrong. If you are having a gas at critical conditions, the behavior of the gas will be far away from the ideal gas behavior, because you will be very far away from the straight line. Go to the point guys. So these are the three main conclusion you need to get from this particular problem. ठीक है बच्चों, तो मैंने आपको कंप्रेसिबिलिटी फैक्टर का सारा चीजें डिस्कस कर दी, एंड आई होप दीज आर सफिशिएंट. गेट एक्सी मैकेनिकल में इससे ज्यादा आपसे नहीं पूछेगा. लेट्स अगेन कम बैक टू द प्रॉब्लम. ठीक है, चलिए अभी प्रॉब्लम पे आ जाते हैं. तो हमने कंक्लूड कर दिया है क्या कि द कंप्रेसिबिलिटी फैक्टर फॉर द गिवन केस इज 0.9. व्हाट वी हैव कंक्लूडेड, द कंप्रेसिबिलिटी फैक्टर फॉर द गिवन केस इज 0.9. दैट वी हैव कंक्लूडेड. ठीक है बच्चों, चलिए सो ये जो अपने पास गिवन केस था, इस गिवन केस के लिए द कंप्रेसिबिलिटी फैक्टर इज 0.9. सो ये अपने पास बड़ी मेहनत से आया है. They have not given, actually in this problem they have not given that. उन्होंने दिया नहीं था, but based on the data, based on the T critical, P critical, based on the reduced temperature, reduced pressure, I observed this value Z equal to this. Now this is nothing but V actual by V ideal. V actual by V ideal. मतलब यार यहीं से आप निकाल सकते हो, दोनों में डिफरेंस निकाल सकते हो. तो V actual निकाल लो, तो V actual कितना आ जाएगा? V actual will be what? वो जो आया था हमारा, इसको मल्टीप्लाई कर दो दोबारा से 0.9 से, इसको मल्टीप्लाई कर दो 0.9 से. तो यहां लिख देता हूं मैं. सो V actual will be 0.9 multiplied by 0.0012137. This is V actual. Okay, but आपसे उसने पूछा क्या? He asked you the difference. उसने तो आपसे डिफरेंस पूछा है बच्चों. So the difference will be V ideal minus V actual, and that will be nothing but 0.1 into 0.0012137. तो ये कितना हो जाएगा? It will be 0.0001237. 0.0012137. This is the difference, guys. So this is the difference. V ideal minus V actual will be 0.1. 0.1 कैसे लिखा बच्चों? ये समझ में आ रहा है? 1 minus 0.9. So 0.1 into V ideal, which is 0.001213. ठीक है. एक्चुअल को मैंने लिख दिया 0.9 और आइडियल तो आपका V आइडियल था ही. सो V आइडियल आपने कॉमन ले लिया. सो V आइडियल into 0.1. ठीक है. तो दोनों में डिफरेंस कितना आ जाएगा? द डिफरेंस इज दिस, एंड दिस इज वेरी करेक्टली इन दिस रेंज. उन्होंने बहुत बड़ी रेंज दे दी थी, तो 0.002 से इससे 0.0001 से, if you are getting answer in this range, your answer is right. बिल्कुल definitely, and our answer is in this range only. 0.0001 to 0.002, this is the range for this question. If you are getting answer in this range, your answer is right. ठीक है बच्चों. So I hope this question concept is very much clear to you. चलिए, ओके. ठीक है, चलो, let us move to next problem. This is next problem, guys, in front of you. ठीक है, चलो. तो बच्चों इस प्रॉब्लम में is asking you the work. There is a gaseous mixture from state 1, this state to this state, the mixture is going, and he is asking the work. Polytropic process है, the process is polytropic. So the work polytropic will be P1V1 minus P2V2 by n minus 1. या इसको आप लिख सकते हो mr T1 minus T2 divided by n minus 1. बट इसमें समझना क्या है? m होगा m टोटल, r होगा r इक्विवेलेंट, T1 minus T2 divided by n minus 1. So the formula is very simple, clear. Formula is very simple and very clear. But you need to calculate R equivalent. भी mixture दे दिया उसने आपको. And for that mixture you need to calculate R equivalent. And you know guys, he has given you the mass fraction. उसने आपको mass fraction दिया है. He has given you the mass fraction. Mass fraction दिया है. But एक गड़बड़ कर दी उसने. ऊपर तो दे दिया mass fraction, नीचे दे दिया मोलर स्पेसिफिक हीट, CPM मोलर, CP मोलर. ऊपर दे दिया मास, नीचे दे दिया CP मोलर. दैट इज अ डिफिकल्टी इन दिस केस. मास दिया था तो अपने को मास वाली CP देता है यार. ठीक है, तो बच्चे कंफ्यूज हो जाएंगे यहाँ पे. तो आपको करना क्या पड़ेगा बच्चों? CP मोलर अगर आपको दिया है, देखो ये फॉर्मूला याद रखो. CP मोलर का यूनिट क्या होता है? इट इज इन किलो जूल पर किलो मोल केल्विन. किलो जूल पर किलो मोल केल्विन. बच्चों इसको डिवाइड कर दो ना मोलिकुलर वेट से. इसको डिवाइड कर दो किससे? मोलिकुलर वेट से. केजी पर किलो मोल, केजी पर किलो मोल. तो क्या आ जाएगा? व्हाट यू विल गेट? दिस विल कैंसिल आउट. यू विल गेट CP ओके, तो अगर कभी भी आपको सीपी मोलर दिया हो बच्चों, सीपी मोलर को अगर आप मोलिकुलर वेट से डिवाइड कर दोगे ना तो आपको सीपी मिल जाएगा, बस ये ध्यान रखना। सीपी मोलर को अगर आप m से डिवाइड कर दोगे यू विल गेट सीपी। गॉट द आइडिया गाइस? सीपी मोलर को यू नीड टू डिवाइड बाय द मोलिकुलर वेट, यू विल गेट द सीपी। तो ये आइडिया आपको समझना है। हालांकि में थोड़ा सा प्रॉब्लम है क्वेश्चन में, आई एम गोइंग टू डिस्कस विद यू, डोंट वरी, but this problem is very important actually, so that's why I'm discussing. There is some kind of data error. So cp1 will be 35.06 divided by m1 कितना हो जाएगा? It will be 12 plus 4, it will be 16. Similarly cp2 will be 28. मैं यहां लिख देता हूं बच्चों, यहां थोड़ा सा साफ साफ लिख देता हूं. So this I'm writing it as 1, this is 2, this is 3, this is 4. 1 2 3 4. ठीक है, तो यहां से आप cp1 निकाल सकते हो. cp1 will be 35.06 divided by m1 which is 16. cp2 will be 28.88 divided by 12 और 16, it will be 28. cp3 will be 29.01 divided by 2 and cp4 it will be 28.87 divided by 28. तो cp1 आ जाएगा, cp2 आ जाएगा, cp3 आ जाएगा, cp4 आ जाएगा. ओके, cp1, cp2, cp3, cp4. मास फ्रैक्शन ऑलरेडी आपको दिए हुए हैं, मास फ्रैक्शन ऑलरेडी आपको दिए हुए हैं, तो आपको फार्मूला क्या लगाना है बच्चों? व्हाट फार्मूला यू नीड टू हैव? cp इक्विवेलेंट इज इक्वल टू m1 cp1, m2 cp2, m3 cp3, m4 cp4 divided by m1 plus m2 plus m3 plus m4. m1 plus m2 plus m3, m1 m2 m3 plus m4. You will get cp equivalent. ठीक है, इसको करोगे तो क्या आ जाएगा आपके पास? cp equivalent. Got the point guys? cp equivalent. Now there is a very important relationship. वो बहुत इंपॉर्टेंट रिलेशनशिप और आपको समझ लेना है. cp minus cv equal to r. cp minus cv equal to r. This you can write it something like this also. cp molar minus cv molar into universal gas constant. cp minus cv equal to r. cp molar minus cv molar equal to r. How you can say sir? कैसे बोल दिया आपने सर? ये कैसे बोल दिया गाइस? अगर मैं दोनों तरफ को m से डिवाइड कर दूं, if I will divide both side by what? Because मेरे को इसको क्या करना था? मोलिकुलर वेट था ना, kg पर किलोमोल. हाँ, kg पर किलोमोल. ठीक है, तो यू नो करेक्टरिस्टिक गैस कांस्टेंट इज नथिंग बट rc. करेक्टरिस्टिक गैस कांस्टेंट rc इक्वल टू यूनिवर्सल गैस कांस्टेंट डिवाइड बाय m. यूनिवर्सल गैस कांस्टेंट डिवाइड बाय m. तो देखो अगर मैं इसको दोनों तरफ से m से डिवाइड कर दूं, सो cp मोलर डिवाइड बाय m, cv मोलर डिवाइड बाय m, यूनिवर्सल गैस कांस्टेंट डिवाइड बाय m. तो ये क्या होता है? व्हाट इज दिस? This is cp minus cv equal to r only. ठीक है, so that's why I mentioned like if you are having cp molar divided by m to get the cp. Similarly, if you are having cv molar divided by m to get the cv, and similarly if you are having universal gas constant divided by m to get the r. तो ये दो रिलेशंस हैं, कोई भी ये याद रख लो या ये याद रख लो. ठीक है बच्चों, तो अगर मैं यहां से, बिकॉज मेरे पास cp इक्विवेलेंट है, cp इक्विवेलेंट है, cp equivalent minus cv equivalent equal to r equivalent. ठीक है, तो r equivalent मेरे पास कहां से आएगा बच्चों? r equivalent will be, you will easily get by r universal divided by molecular weight equivalent. r universal gas constant divided by equivalent molecular weight. ठीक है, सो अगर कभी भी इक्विवेलेंट ये निकालना हो तो ये तो 8.314 हो जाएगा और इसको डिवाइड कर दो इक्विवेलेंट मोलिकुलर वेट से. ठीक है, और इक्विवेलेंट मोलिकुलर वेट कहां से आता है बच्चों आपका? इक्विवेलेंट मोलिकुलर वेट m इक्विवेलेंट you will get it from m1 plus m2 plus m3 plus m4 divided by m1 m2 m3 m4. तो इसको करोगे तो m इक्विवेलेंट आ जाएगा. मास फ्रैक्शंस आपको दिए हुए हैं, सबके मास फ्रैक्शन दिए हुए हैं, तो यू विल गेट द इक्विवेलेंट मॉलिक्यूलर वेट। तो कहने का मतलब क्या है बच्चों, व्हाट आई वांट टू टेल यू इन दिस क्वेश्चन, because that concept is very important. What I want to tell you in this question, guys, you will be easily able to calculate the equivalent R. Already I told you how to calculate equivalent CP, so you will get equivalent CV also. These all will be known to you, equivalent CP, equivalent CV, equivalent R. तो अगर ये आ गया तो आपके पास गामा या N भी आ जाएगा. You will get N also, N equal to CP by CV. You will get N equal to CP by CV also. Got the point, guys? थोड़ा सा complex question है, but the motive is not to, you know, like there are chances these type of questions asking in GATE examination. You know, guys, concepts are more important. We are discussing each and every different concepts, multiple concepts also, so that if they are asking you some kind of single concept question, that also you will be easily able to answer. So what I told you, guys, from this given data, you will be easily able to calculate CP equivalent, CV equivalent, R equivalent. Based on that you will get N also, N equal to CP by CV. तो इस एक्सप्रेशन में अगर आप देखोगे, ये जो एक्सप्रेशन था हमारे पास, N आपके पास आ जाएगा, N आपके पास आ जाएगा, T1 T2 आपको दिए हुए हैं, टेम्परेचर T1 is 298, टेम्परेचर T2 is 400 केल्विन. T1 is 298, द टेम्परेचर T2 is 400 केल्विन. ठीक है, वो भी दोनों आपको पता है, T1 T2 both are given to you. ओके, मास टोटल इज ऑल्सो, यू नो, मास फ्रैक्शन क्या है, देखो इसका मास, इन सबका जो मासेस है, मास टोटल मास फ्रैक्शंस आर गिवन टू यू, तो वहां से आप इनका मासेस भी निकाल सकते हो. ओके, इजीली यू कैन फाइंड आउट देयर मासेस ऑल्सो. तो दिस ऑल दिस थिंग्स आर नो, एंड देन इजीली यू विल गेट द वर्क आउटपुट. आपके पास वर्क आ जाएगा, ठीक है, ये वर्क आ जाएगा. और अगर आप ये निकालते हो, यू आर गोइंग टू गेट आंसर इन द रेंज ऑफ माइनस, बिकॉज यू नो इनिशियल टेम्परेचर इज लो, द फाइनल टेम्परेचर इज मोर, T1 is less than as compared to T2, so you are going to get the negative answer, and that is right for this question. You will get answer in the range of -360. आपका जो आंसर आएगा इससे -360 के आसपास आएगा. यस, बिल्कुल सही है. आपसे वर्क पर केजी पूछा है, तो दिस मास टोटल यू कैन टेक इट 1 kg. इसको 1 kg ले सकते हो, दिस इज 1 kg. Okay, so R equivalent, I told you how to calculate R equivalent. T1 T2 both are given to you, and also you will get from this data ratio of CP equivalent by CV equivalent. CP equivalent by CV equivalent वहां से आपका आ जाए. तो मैंने इस क्वेश्चन को दो तरह से ट्राई किया बच्चों. I tried this question by two ways. First is this, ये जो तरीका था, because you are having a mixture and this is a right approach actually. बिल्कुल सही अप्रोच है. आपने CP equivalent निकाला, CV equivalent निकाला, and then you have taken the ratio of CP equivalent by CV equivalent. From that I got the answer -366. ओके, -366 किलो जूल पर केजी. दूसरा एक मेरे दिमाग में क्या आया कि व्हेन दीज रेंज टेम्परेचर्स आर गिवन टू यू, फर्स्ट रेंज सेकंड रेंज गिवन है, तो व्हाई नॉट टू अप्लाई हियर द T2 by T1 इक्वल टू P2 by P1 की पावर n-1 by n. इसको x मान लेते हैं, तो T2 by T1 इक्वल टू P2 by P1 की पावर x. तो ये पता है आपको, T2 पता है, T1 पता है, P2 पता है, P1 पता है, सो इजीली यू विल गेट x.